Good morning, everyone. And good morning to all the participants who are online. So today's my topic is inverse trigonometric functions. So before taking up that topic, I pick up the thread where I left yesterday. I, yesterday we did not reach to the level that what are inverse functions. And here we are talking about inverse functions. So I am picking up the thread where I left yesterday. So A is a non-empty set with us. B is also a non-empty set with us. Order of A I am taking as M. So order of B we are taking as N. Then we can form A cross B. A cross B can be formed. And we know that what is the order of A cross B? That's M into N. So we know the number of relations from A to B. So number of relations from A to B. Well, that is 2 raised to the power m into n. Then what is the number of functions? Number of functions from this A to B. So what is the number of functions from A to B? That was equal to how much? N raised to the power m. That was the number of functions. And then we were talking about one function and onto functions. So what is the number of one functions? One functions. Number of one functions, that was 0 if. What was the situation? N is less than m. If n is less than m, otherwise it is npm, provided n is greater than or equal to m. That was what we discussed. And then we were talking about the number of onto functions. Number of onto functions. I explained yesterday that what we mean by an onto function. To decide about an onto function, either that range should be equal to codomain itself, or the alternative ways was corresponding to every element of B, there must exist an element in A such that the image turns out to be that very element. That was the alternative way. And then we were finding the number of onto functions. What was the number of function? It was 0 in what situation? Number of onto functions was equal to 0 in what situation? N is greater than m. So that was 0 if n is greater than m. And yesterday I was trying to write what is to be written at this place. So today I am writing the result. So here it is sigma of this. Minus 1 raised to the power n minus r. N minus r, it is ncr into r raised to the power m. And this r is varying from 1 to n. R is varying from 1 to n. And I am not driving this result. Well, yesterday I was taking up a particular example. That particular example I explained that if there were only 2 elements on this side, and here are 4 elements on this side, say A, B, C, D, like this. Here is set A, this is the set B, and this is the situation provided your n is less than or equal to m. If n is greater than m, that was 0, and this is the situation when n is less than or equal to m. So I took a particular case that was like this. So what was the number of relations? It was 2 raised to the power 8. And what was the number of functions? Number of functions was 2 raised to the power 4. Number of functions. What is the number of one function? One function, no one function. So because here the order is less than, so no one function. What was the number of onto functions? There were the possibility. And yesterday, somehow or other, we decided if all the elements, they are mapped to alpha, or all the elements are mapped to beta, then these 2 functions will not be onto. If all are mapped to alpha, then the beta will be left uncovered. So that means this function will not be onto. Or if all are mapped to beta, then that alpha will be left uncovered. So here we notice further that the number of onto functions turns out to be 2 raised to the power 4 minus 2. Then I took a little bit general situation. On this side, there may be more number of elements. So if there are m elements on this side, but strictly 2 elements on this side, strictly 2 elements on this side, then the number of onto functions is 2 raised to the power m minus 2. If this m is definitely greater than or equal to 2, this must be greater than equal to 2, only then this type of result holds. And then I was taking up one more particular situation, and that was instead of this alpha beta, say I created another problem, that if there are 3 elements on this side, if there are, so yesterday I left really at this stage, there were 4 elements on this side, 3 elements on this side, then what was the number of relation in this situation? If you look upon the number of relations, is 2 raised to the power 12. So number of functions is 3 raised to the power 4. Number of functions is 3 raised to the power 4. What is the number of onto functions? This is no number of one functions. Number of one function is 0. But what was the number of onto functions? And yesterday I was quoting a result from permutation combinations, where there we decided that these 4 things, they are to be divided among these 3, and everyone must get at least 1. Otherwise, it will be left uncovered. So that can be done only like this, 1, 1, and 2. That is the only way left. That is how we can partition these elements. And then the result was like this, 4 factorial divided by 1 factorial, 1 factorial divided by 2 factorial. Because these two, they are same, still to be divided by 2 factorial and into 3 factorial. Yesterday I was just at this place when we left. So then this result turned out to be 36. That was the situation. And here instead of 4, we can pick up the 5 elements. If we increase the number of elements on this side, instead of 4, if there are 5 elements, if there are 5 elements on this side, this is a very, very good question from the examination point of view. Very good question from the examination point of view. Many times this question is asked in permutation combination. So sometimes this question may be asked even in these functions. A very good problem from examination point of view. If there are 5 elements on this side, 3 elements on this side, then what is the number of onto functions? Number of relations is very simple. This is 2 raised to the power 15. And what is the number of functions? Is 3 raised to the power 5. Number of functions is 3 raised to the power 5. Then what is the number of one function? 0. Number of onto functions, that is the problem. That is the difficult one. That what is the number of onto functions? So how you can divide these 5 elements? These 5 elements to be divided among these 3. So what is the way out? Yes, it is either 1, 2, and 2. That is one process. Is there any other way out? Correct. So that means 1, 1, 3. These are the 2 choices. So here instead of 1 choice, we have got 2 choices, that either we'll have to divide it like this, 1, 2, and 2, or we'll have to divide it as 1, 1, and 3. Now, how to divide it in 1, 1, and 2? 1, 1, and 2, how to divide it in 1, 1, and 2? So apply this type of rule. So it is 5 elements. It is to be divided like this, 1, 2, and 2. So it is divided by 1 factorial, divided by 2 factorial, divided by 2 factorial, yet to be divided by how many they are similar. So there are 2 elements similar, to be divided by 2 factorial into 3 factorial. Into 3 factorial. This is how this has been decided. And plus, then this is to be decided like this. So 1, 1, and 3. So that means 5 factorial divided by what? 1 factorial, 1 factorial, 3 factorial, still to be divided by 2 factorial, and into 3 factorial. So that is the net answer to this problem. You can simplify it. I think this is not a problem to simplify it. Check it that what you are getting. This is 120. So divide by 8, 15 into 6. So we are getting 90 at this place, and plus from here. So this is a 120 divide by this 3 factorial will cancel out. So plus 60, 90 plus 60, 150. So this you can decide like this, or we can apply a formula. This formula is there. We can apply a formula. Formula can be applied in case of 2 elements. Formula can be applied in case of 3 elements. This formula can be applied. So we can apply the formula, or we can get the result for this. And even for these 3 elements, I have got another simple result. I am quoting it for you. So it is a number of onto functions is 3 raised to the power m minus 3 into 2 raised to the power m minus 1. Provided there are 3 elements on this side. Strictly 3 elements on this side. If there are 3 elements on this side, and on this side greater than or equal to 3, definitely greater than or equal to 3, only then this will have meaning. Otherwise there will not be any onto function. Onto functions are possible provided n is less than or equal to m. So, or in other words, this must be greater than or equal to this number. Then instead of 5, this formula you can put it as 5 and see whether you are getting 150 as the answer or not. You are getting 150 as the answer. Put m equal to 5 in this case. On this side I am restricting, specially restricting to 3 elements. Specially restricting to 3 elements on this side. And on this side, if there are 5 elements, apply this, put m equal to 5 and see what answer are you getting. Put m equal to 5 here in this formula. Are you getting the same answer? So you have got 2 methods. You have got 2 methods with you. Either you can apply this formula directly, or you can go through this process. We can go through this process, or still alternative, we can apply this formula. We can still apply this formula. But this formula is quite convenient as far as this is concerned. This is concerned instead of these 2. Very quick result if you want to obtain. We can obtain a very quick result provided we know this type of formulae. So this formula is specially meant for this very particular type of question. But here we can still increase the number of elements on this side. Instead of 5, you can increase 6, 7, any number of elements. And usually this question in IIT competitions, that is asked normally for 5 elements on this side. Strictly 5 elements on this side. That is what I find the question many times in the paper. After 2-3 years, this question goes on repeating in one form or the other. The shape may be different of asking the question remains the same. If this is known, that then this question can be asked. Well, from here, so we have got the idea of 1-1 function, we have got the idea of onto function. So what is a 1-1 onto function? 1-1 as well as onto. We separately know what we mean by 1-1 function. Again, we separately know what is an onto function. Now coming together, that this must be 1-1 as well as onto. So what condition should be satisfied? So here in the first situation was like this. That is in that case. What was that case? That is already with you. So number of 1-1 functions. What was the number of 1-1 function? That was equal to 0 provided your n is less than m. N is less than m. And otherwise the result was npm. And now we need 1-1 as well as onto. So what was the situation in this case? So in this case, n is greater than or equal to m. N is greater than or equal to m, we can get 1-1 functions. And this n is less than or equal to m, we can get onto functions. So when we can get both, so that means n must be greater than or equal to m as well as n must be less than or equal to m. Well, from here it follows that when n is equal to m, only then we can have both these functions as 1-1 as well as onto. For 1-1 as well as onto, what should happen is, from these 2 results, it strictly follows that for 1-1 onto functions, both, well, that will happen only if n and m, they are equal. And what will be their number? Instead of getting the answer from here, I think much easier to get the answer from this place. If n is equal to m, if n is equal to m, then the number will be npn. And what is npn? npn. Apply the formula for npn. You know the formula for NCR? What is the formula for NCR? N factorial divided by n minus n factorial. So it is n factorial divided by 0 factorial. And you know 0 factorial is 1. So that means n factorial. So number of 1, 1 on 2 functions. What will be the number of 1, 1 on 2 functions? That will be equal to n factorial. So 1, 1 as well as on 2, they are both possible provided we have n is equal to n. And well, for an inverse function, it is essential that our original function must be 1, 1 as well as on 2. Only then we can think about inverse functions. Otherwise, the inverse functions will not exist. So such functions which are 1, 1 on 2, they are also called bijections. Another name for them is bijection. So what is a bijection? Bijection, it is a function which is 1, 1 as well as on 2. 1, 1 as well as on 2. That type of function is known as a bijection. Bijection. So for inverse functions, what we need is that the original function must be 1, 1 as well as on 2. So I have got this is a and B non-empty sets. Let its order say is equal to, now in this case, if I need m and n, if I need 1, 1 as well as on 2, m and n, they must be both equal. So order of A must be equal to the order of B. To see that there is a function which is 1, 1 as well as on 2. This time I need 1, 1 as well as on 2 function. And if their order say is equal to n, then the number of such functions will turn out to be equal to n factorial. So here I have got a situation like this. So there is a set A containing n elements, a set B also containing n elements. The elements may be different. The elements may be different. Here it may be A, B, C, D like this. Here may be alpha, beta, gamma, delta like that. So elements may be different. Here may be numbers 1, 2, 3, 4. If I count A, B, C, D on this side, whatever the elements may be there, that is a different story. But the number of elements that must be the same. And now for so here is a function which is 1, 1 as well as on 2. It is a function from A to B. It is a function from A to B. So we have got a function. And now this function is 1, 1 as well as on 2. I need an inverse function. Supposing I have got x and its image turns out to be y. Under that rule f. So under that rule f, let the image of x be y. Or in other words, this y turns out to be equal to f of x. Y is equal to f of x. Now I need inverse function. Well, for the inverse function, so inverse function means I want to go from this place to this place. Inverse, I want to go back. I want to go back. That is the meaning of inverse function. So inverse function for this purpose. So if I need a function from this place to this place, that means corresponding to every element from here, we must get an answer. Corresponding to every element from here, we must get an answer. So does it mean that the original function must be on 2? If the original is not on 2, if original function is not on 2, you find that there are some elements which may be left uncovered. And then corresponding to that element, if I want to go back, then where to go back? There is no place to go back. So that means original function must be on 2. It is a necessity. It is our necessity for this function to be a on2 function. Otherwise, we cannot think about inverse function. Inverse function is not logical, because for the inverse function, corresponding to every element, we must get an image on this site. And that is possible only if our original function is an onto function. Is it right? So it becomes a necessity for a original function to be an onto function, or to get an inverse function. And moreover, now corresponding to this element, you can't think of two elements. Corresponding to this element, you can't think of two elements. So this element cannot be attached with two elements. You are attaching it with two elements. So you are getting two images. You are getting as two images. Well, that will not be a function. And that means original must be a 1, 1. Original function must be 1, 1. If original is not 1, 1, supposing this element also goes here. Supposing this element also goes here. Now from this place, if you want to go back, then you don't know whether this is to be written or this is to be written. So again, it becomes our necessity that original function must be a 1, 1 function. That must be 1, 1. Otherwise, how to go from this place? Now from here, you want to go home. And there are two places, whether this home or this home, that's not known. We'll be very much in difficulty. So very much clear situation. So corresponding from this place, there must be only one element on the other side. And that's possible only if you have your original function as 1, 1 as well. Well, for an inverse function, if you want to have an inverse function, so it is our necessity that original function must be 1, 1 as well as on 2. So it becomes a necessity for this function to be 1, 1 on 2. Only then we can talk about inverse functions. And well, for the inverse function, if your original is 1, 1 on 2, now think like this. Original is 1, 1 as well as on 2. That means corresponding to every element, we'll be getting an answer. And then we'll be getting a unique answer. We'll be getting a unique answer. That means inverse function is logical. Inverse function becomes logical provided your original function is 1, 1 as well as on 2. Again, moreover, the situation is clear. This was the domain. This was the domain. This was the range. Is it all right? And now from here, you want to go from this place to this place. So here I want to have inverse function. Inverse function usually written like this. Original is written in this manner. So inverse is put just, don't think as a power minus 1. Don't take it as 1 by f. Not like this, inverse. So we are reading it as the inverse function. That is how we write this inverse function. So f, we write minus 1 to indicate the inverse of that function. Well, for the inverse function, is it clear from this situation that this should become the domain? For this function, this should become the domain and this should become the range. So domain and range, they are automatically interchanged. Domain and range, they are automatically interchanged. So there should not be any burden on our brain if you know the original situation. If you know the original situation, then if the domain and range of the original function are known, then the domain and range of the inverse function are also known. They are just reversed. Whatever was the range, that becomes the domain, and whatever was the domain of the original function, that becomes the range. Is it clear? Is that idea coming clear about the inverse functions? So don't take double burden on your mind that you are to think about the inverse functions, their domain, their range. Well, that will be very much clear to us, provided we know the situation, that what is the domain and the range of the original function. Well, for your inverse function, it's not only trigonometric inverse function. Anywhere we can go to any place. Well, for the inverse function, it will be essential that to have our original function as 1, 1 as well as on 2. Only then we can talk about the inverse functions. Well, for the inverse functions, the domain and range, they also become automatically clear, provided we know the domain and the range of the original. If the domain and the range of the original are known, then automatically the domain and the range of inverse function are also known. And very simple, if that x goes to y, if x goes to y, now y will go to what? Y will go to x. So that is a type of situation. So for the inverse function, what should happen is f inverse of y, that should lead to x. So x goes to y. Then under inverse rule, that means y should go to x. So it means that if y is equal to f of x, and this will imply that f inverse of y is equal to x. This will imply only under the condition that f must be bijection. It must be 1, 1 as well as on 2. 1, 1 as well as on 2. If something is missing, then we cannot go back. We can go back provided this f is 1, 1 on 2. Otherwise, we are not allowed to write like this. And now if that is there, so both the things, they become same. So if y is equal to f of x, if the image of x is y under original, so under the inverse, what will happen is the image of y will become x. So if x goes to y, then y goes to x. That is how these functions are working. So can I look to page 2 yesterday? Page 2. Question number 11, I want to. No, page 2. Not this page 2, yesterday's page 2. Question number 11, I want to see. So here is a very good question. This is from your material itself, Udaan, and a very good question. So here is the function from a to b defined like this. F of x equal to minus x square plus 6x. I am referring to this question. So look upon this question. This will open up the way for our inverse trigonometric functions. So this is a function given to us. F of x is equal to minus x square plus 6x minus 8. That is the function. Now can I write like this, negative being taken out, x square minus 6x. I want to complete the squares. Well, to complete the square, how much is to be written? 9. This minus is being taken out. We are getting x squared, then minus 6x. I want to complete the squares. To complete the squares, 9 is to be written. And now the rest, they are to be balanced. Minus 9 we have written practically, so plus 9 and minus 8. The whole thing is balanced. Notice everything is fine now. Is it all right? So this is further equal to, so I can call say as y, f of x is y is equal to minus x minus 3 whole square, then plus 1. 9 minus 8 is plus 1. Is it all right? I am transposing this 1 to the other side. So here is y minus 1 is equal to minus x minus 3 whole square. You know what is this curve? This is an equation of a curve. This coordinate geometry you have read enough. This is an equation of a curve. So what curve? Yes, come out. It's a parabola. It's a parabola. What type of parabola? Downward. It is a downward parabola. What is the vertex of this parabola? Vertex of this parabola. Is it clear? Vertex comes from here. X minus alpha, y minus beta like this. So vertex of this parabola becomes x coordinate is always to be written first. And then here is 1. So vertex is 3 and 1. Vertex is 3 and 1, and it is a downward parabola. Well, we can have a graph. We can have a graph of this with vertex at 3, 1 and a downward parabola. So can we think about the graph of this? I am marking the x-axis, the y-axis. So here is a 1, say 2, 3, 4 like this. So it is a 3 and 1, 3 and 1 somewhere here. 3 and 1. So this becomes the vertex. So here is the vertex of this parabola. 3 and 1 approximately I'm thinking of. And then it is a downward parabola with this point as the vertex. This is a vertex and it is a downward parabola. And moreover, can you find that where it will meet your x-axis? Can you find the point of intersection with the x-axis? So x-axis means what to be done? Y is to be put as 0. So y is to be put at 0, 0 here, or why not to put at this place? We are inputting y equal to 0. This is your y. So that means minus x square plus 6x minus 8 is equal to 0. Even here, if you want to write, you can put y equal to 0. Then you will have to little bit simplify, go back. So that is the type of situation. Or from here, can I take negative out? So here is x square minus 6x plus 8 is equal to 0. I hope we can factorize x minus 2 into x minus 4 is equal to 0. That gives you x equal to 2, x equal to 4. X equal to 2, x equal to 4. And y coordinate is already 0. Y coordinate is already 0. That means this curve passes through the points 2, 0 and 4, 0. This curve will pass through the point 2, 0 and 4, 0. So 2, 0. So here is a point 2, 0 and this is a point 4, 0. So curve passes through these 2 points. So here is a downward parabola. It is going to cross this. Somewhere it is definitely going to cross this. Don't think that it is bounded. Goes on. There is unlimited. Don't think of that a floor will stop it. No floor will stop it. No earth will stop it. It's just going down and down. So that is the type of situation. So here we have got this vertex. This vertex is 3 and 1. Vertex is 3 and 1. So this is going like this. Can we find the domain of this function? Can we find the range of this function? Domain and range. Look upon the domain. Well, for the domain of this function, there is no denominator in this problem, or you can think of the denominator is 1. So we are not getting any 0 in the denominator. And there is no square root involved. So there is no problem at all. So as far as the domain is concerned, well, the domain of the function, that becomes equal to R. The domain becomes R. Here is your this function. So that is the domain. Can you find the range? Range means the values of y. Can you get the values of y? Range, that is the values of y. I think here is y. In place of this, better to think of from here. I will try to get the values of y from this place. How to get the values of y? I am trying to find the range of this function. Range of this function, trying to get the values of y from this place. So what is x minus 3 whole square? I hope that this is greater than or equal to 0. X minus 3 whole square is definitely greater than or equal to 0. But there is a negative sign. So that means from here it follows minus x minus 3 whole square is less than or equal to 0. Is it all right? I can add 1. So here is 1. 1 is to be added. So that means here what I find is minus x minus 3 whole square plus 1 is less than or equal to 1. That means y is less than or equal to 1. Y is less than or equal to 1. So y is less than or equal to 1. That gives you the range. What is the range? The values of y. Even this diagram indicates. Well, diagram is speaking of about its range. What are the values of y? Up to this place. The values of y up to this place. All these negative values. All the negative values. If your diagram is there, we can definitely read it from the diagram. We can find it from the diagram that what is the range. Anyway, I have obtained the range. We observe it from the diagram that the range is minus, what is? Range in this case turns out to be equal to minus infinity to 1. That is the range. The domain and the range. Is it all right? So domain is known, the range is known. Is this function 1, 1? Is it 1, 1? How to decide that it is 1, 1? If the figure is with us, very easy to decide about that. This function is 1, 1. Even at this place. Here you notice corresponding to 2, we are getting y equal to 0. Corresponding to 4, we are getting y equal to 0. So if a horizontal line meets the graph in more than 1 points, you can draw the horizontal lines. You can draw the horizontal line. If you come across even with a single line which meets the graph in more than 1 points, if it meets the graph of the function in more than 1 points, that means this function will not be 1, 1. Quite clear, even from this figure, this much. You notice here is the value of x, and here is the value of x. So corresponding to this value of x, y is same. Corresponding to this value of x, y is the same. So that means corresponding to these two values of x, we are getting the same value of y. We are getting the same value of y. That means the different elements, they give you the same answer. Different values, they give you the same answer. That means this is not equal to 1, 1. So if the graph is with us, then it's very convenient to decide whether the function is 1, 1 or not. Otherwise, we'll have to work it out. Otherwise, we'll have to work it out. But once the figure is with before us, then we can draw the horizontal line and decide. At once, the situation will be very clear that if a horizontal line, even if one horizontal line meets the graph in more than 1 points, then that will not be a 1, 1 function. So this function is not 1, 1. Is it all right? Well, I need a 1, 1 as well as 1, 2. Now, my problem is this. My problem is this, that I need a 1, 1 as well as onto function. And this as a whole before us is not a 1, 1 onto function. Now, can you take up a part of this function? Part of this as a whole, this is not going to be a 1, 1 function. It is not 1, 1. Onto we can think of, we can take up the values of y only from minus infinity to 1. Minus infinity to 1. His question is like this. Very severe question. A to B. I want to have from A to B. And what is A in this case? A in this case, we are getting the range, the domain. Domain is all real. Domain is all real. And what we are getting B? B we are getting as minus infinity to 1. Well, but this as a whole, it does not become a 1, 1 function. Now, if I take, especially you look upon this portion, if I take only this part, if I take only this part, I ignore this part. I leave this part. I take up only a part of this. I take up only this part. Will this be a 1, 1 function? If I consider only this part, will it be a 1, 1 function? So this will be a 1, 1 function, provided I consider only part of this. Half of this, I am leaving half on this side, half on this side. So then this will be 1, 1. So it will become a 1, 1 onto function. So when it will become 1, 1 as well as onto. So see the situation. Look upon the situation. If it is from 3 to infinity, 3 to infinity, 3 to infinity, like this. This side, he is taking this as first. He has taken from 3 to infinity, 2 parts. I am breaking it into 2 parts. One is this part, the other is this part. Is it all right? Now here is this number 3. So he is considering from 3 to infinity. Of course, this goes on, goes on, goes on. So 3 to infinity. If I consider 3 to infinity, I am considering only this part. I am considering only this part. So this part becomes a 1, 1 onto function. You notice, if I consider 3 to infinity, A as 3 to infinity, and B as minus infinity to 1, B as minus infinity to 1, then it will be a 1, 1 onto function. So the question is this function defined by this is a bijection. This function is a bijection. Bijection means 1, 1 as well as onto. So it will become a 1, 1 onto function, provided we restrict our domain from 3 to infinity. Of course, range minus infinity to minus 1. Is it all right? Is it clear? Coming the situation clear? If I consider this part, so this will become a bijection. This will become 1, 1 as well as onto. Then the second is this, minus infinity to 3. If I consider this side, so here what is the domain? Minus infinity to only up to this, all these numbers they are coming. So this is just the values of x, minus infinity to 3. Is it all right? And then the range is here, this part, minus infinity to 1. So range is there, that part. So that means again this will be a bijection. This will be bijection, provided this happens, this happens. So there are 2 choices, correct choices. The correct A is a correct choice, B is also a correct choice. As this is not a correct choice, because in this case range he is talking about from 1 to infinity. Range is not 1 to infinity. The range is from minus infinity to 1. So that is violated. So again from A is from 3 to infinity, range from 1 to infinity. Range is not from 1 to infinity. So only these 2 choices, they are correct. And that really gives you an opening for at how we can go through these inverse trigonometric functions. It's a very good question from the examination point of view. A very good problem on this functions. So really a good one from as far as the functions are concerned. Why did we understand the meaning behind it? So this function as a whole, this was not 1, 1. Some type of coordinate geometry was also involved in it. Some depth was needed as far as this question is concerned. So now what about inverse? Here you notice what is your sine function. I call it as f of x is equal to sine, or I call y is equal to sine of x. This is your sine function. Inverse trigonometric functions. I am talking about inverse trigonometric functions. So can you think about its domain and range? What is the domain of this function sine x? What is the domain of sine x? All real numbers. Don't think about angles. Old days, very old days, those are gone. So don't go 1 century back. Think the present situation. So this x is a real number. So domain is all real numbers. So as far as the domain is concerned, domain of this function is all reals. What is the range of this function? Range. Minus 1 to 1, closed interval. That's the domain of range. Can we have the graph of this function? We can have the graph of this function. So here let us have the graph of this function. I need its graph. Unless I know the graph, I will not be able to explain what we mean by an inverse function. So this is a pi somewhere here. This is pi I am marking. I am marking 2 pi. Then I am marking pi by 2 here, 3 pi by 2 at this place. Then minus pi on this side, like this, minus pi by 2 at this place. So, and above 1 unit, your graph should also be appearing logical, somewhat logical. So this is a little more than 3.14. So pi stands for 3.14 like this, and here we are to go 1 unit. So approximately that should be there. Don't take 1 like this. If you take 1 like this, that will not give you a correct shape of the graph. So I want somewhat a realistic shape of the graph. Is it all right, what I am saying? So think about your scale as well. So about 1 unit on this side, about 1 unit on this side. So our graph will lie between these lines. The graph will, this y will vary from minus 1 to 1. Y varies from minus 1 to 1. Is it all right? So this should lie between these two, not far away, just that line, present a line like this. And 0, sine 0 is 0, and sine pi by 2 is 1, and then sine pi is 0. So graph is really something like this. And then from here, it's pi by 2, it's coming like this. It's going in this way, going like this. And even from this side, if you want to have, the graph will be like this. So it goes on repeating. And here you notice this graph repeats after gap of 2 pi. This graph is repeating after a gap of 2 pi. So this is a periodic function. We call it as a periodic function, provided it repeats. If the graph repeats and repeats after how much gap? Minimum gap you find. Of course, if you take a gap of 4 pi, then again you will find that it is again repeating, but minimum gap. So that minimum gap we find is 2 pi. So graph is really repeating after a gap of 2 pi. So we find that this function is a periodic function with period 2 pi. So period is known as 2 pi. Now, is this function 1, 1? Is it 1, 1? Decide it. We can make it as onto, because we can consider that from minus 1 to 1. If I consider minus 1 to 1, I can make it onto. But is it 1, 1? No, it's not 1, 1. So we need 1, 1 as well as onto. For inverse functions, 1, 1 is required, onto is also required. Otherwise, we are nowhere. We'll be just moving away. So what portion I should take? so that it becomes 1, 1. As a whole, it's not 1, 1. That's very clear. If I draw a horizontal line like this, well, it's meeting here, it's meeting at this place, further meeting here, again meeting here. So this is definitely not going to be a 1, 1 function. At this place, I have got this value of x, I have got this value of x, getting the same value of y. Horizontal line, if a horizontal line meets the graph in more than 1 point, it does not remain a 1, 1 function. Very much clear from the figure. Now, which portion should I select so that it becomes 1, 1? As in our previous problem. In the previous problem, I break that in two parts to decide that it becomes 1, 1. I took one this part, the other was that part. Only 2 parts. But here there are many situations like this. So which part should I select? The best possible one. And the maximum. We want to use the maximum. Don't think of that you take only a small part. You will think of that I take only this part. I take this part only. This will become 1, 1. But take the maximum. So what maximum parts you can take? Maximum selection you can make, that this becomes a 1, 1. Look upon the diagram and see the situation. What maximum parts you can select, that this becomes 1, 1. Are you looking at the figure? And decide which part should we take, maximum part we want to take, so that it becomes a 1, 1. Should I take from here to here? If I look the graph from this place to this place, from this place to this place, that is the maximum whatever we can do. If we go beyond, it will not remain 1, 1. If we go beyond, it will not remain 1, 1. So maximum what we can select is from here to here. So that means from minus pi by 2 to pi by 2. From minus pi by 2 to pi by 2. So we cannot go as a whole. Domain cannot be taken as a whole. So we have to choose some parts. And the maximum part we have to choose. Maximum part. So either we can choose this part or we can choose this part. I can choose this part as well. I can choose this part as well. But I want to remain somewhere near my home. That's always the intention, that one should remain somewhere near the home. And home is your origin. So we want to remain near the origin. So which is the best suitable things which we should select? That the most suitable thing to be selected is from minus pi by 2 to pi by 2. So domain we'll have to restrict. We can't work here. So we will have to restrict ourselves. Domain is from minus pi by 2 to pi by 2. Of course, range is from minus 1 to 1. So if I go from here to here, so values of y, all these values of y, all these values of y, they will be allowed. So that means minus 1 to 1. So range is from minus 1 to 1. Domain is from minus pi by 2 to pi by 2. So that means this is the most suitable part. And for this part, I can have the inverse function. So if I take my f function in this manner, here is the f function, provided I restrict the domain from minus pi by 2 to pi by 2. And then, of course, range, there is no problem as far as the range is concerned. Range was very much clear. Domain and range. The main problem was about that domain. We have to think about the domain, that what a domain has to be selected so that it becomes a 1, 1 function. So if I select the domain like this, I restrict myself only to this part. Restricting myself only to this part, then it will be an inverse function. So what will be the inverse function? If y is equal to this, then what will be that inverse function? Inverse function is written like this. If f is your inverse, so f inverse of x, that will give you y. F inverse of x will give you y. Y was equal to f of x. Y was equal to your f of x. So y was equal to f of x. Y was f of x. So that is your inverse function. Or in other words, here is sine inverse function. And that how that sine inverse function is to be written? So f of x or y was equal to sine of x. And then inverse function to be written like this. Here is the inverse. So sine inverse of y, that becomes x. Sine inverse of y. It is to be read like this. Sine inverse y. Don't take it as power minus 1. 1 over. Don't do it like this. That's not the meaning here. Here the meaning is inverse. So sine inverse of y, that becomes x. Provided your y is equal to sine x. And you restrict the domain. That's very clear. If you don't restrict the domain, we cannot have the inverse function. For the inverse function, some ideas, they must be clear in our brain, that original function must be 1, 1, as well as on 2. It must be bijection. Only then we can think about inverse functions. So here is the inverse function. And this is known as the principal value branch. This branch is known as the principal value branch. There are other branches as well. They are not named as the principal value branches. Principal value branch means in particular this branch. In particular this branch, that's known as the principal values branch. Unless mentioned otherwise, we'll always restrict ourselves to principal values. We shall restrict to ourselves in principal values. Anyway, your material, I'm a little bit upset with that material. So whatever in the very first 2 pages of second page and so on in that material, is writing more than 1 answers. If you write more than 1 answers, that means it does not remain a function at all. So that will violate the definitions of the functions. And even your JE syllabus, quite clearly they have mentioned that only principal values. Only principal values. So don't go through that Udaan material as a whole. We are to find out what is appropriate. So whatever is not appropriate, that we are going to cut down. We have to cut down. There is no choice. Otherwise, that will violate the definition of the function itself. So one answer, one value of x can't give you more answers. If you are getting more answers, we are not talking about the function at all. So we have to think it properly. So that type of situation. So here are your inverse functions. And what about their graphs? If you think about the graphs, the only change will be that for the inverse function, this will become the domain, this will become the range. Original function, this is the your domain, this is the range. For the inverse function, now no burden on the brain, absolutely no burden on the brain. So that means this should become your domain, this should become the range. So that is a type of situation. Instead of y, normally here we talk in terms of x. So here we say sine inverse of x is equal to y if and only if. Sine inverse of x is equal to y if and only if y is equal to, if and only if this x is equal to sine of y, or sine y equal to x. You can say sine y equal to x or x equal to sine y. What about the values of x here? This x. That means its domain. Domain of inverse. Domain of inverse. What is the domain of inverse? So here is the domain of inverse. That is the range. If you think about this, this is your original. So what is the domain here? What is the range at this place? So here domain, as far as this function is concerned, this is the domain, this is the range. Is it right? That is the situation. So no burden should be there on the brains. So can I see the third page? Today's first page. So here is the function, sine inverse of x. That's the domain, that's the range. And I am talking only about the principal values. Is it right? So that is a type of situation. And moreover, something more can be understood about this. X and y, they are just interchanging the role. X and y, they are interchanging the role. So this is the graph of the original function. So where will be the graph of your inverse function? Can we think about the graph of the inverse function? Graph of inverse function. The only change will be the value of x becomes y becomes x. For example, if there is a point 2, 3, there is a point, coordinates are 2, 3. Then if they are interchanged, that becomes 3, 2. So where will be that point 3, 2? You mark a point 2, 3 somewhere. You mark a point 2, 3, 2 units on this side, 3 units on this side, 2 and 3 somewhere here. So here I am marking a point whose coordinates are 2 and 3. And now interchanging the role. If I interchange the role, so I should have to mark 3, 2. So 3, 2. So 3 on this side and 2 on this side. And if you draw a line like this, you notice there will be just the reflection. There will be just the reflection of these two. So if really you want to learn their graph, the best way to learn their graph is don't put the double labor. Can I see this graph? I think maybe the last page, today's last page. Today's last page, maybe this graph page. Right. So here I have shown this graph only from minus pi by 2 to pi by 2. Minus pi by 2 I should have marked. Anyway, here is minus pi by 2 to pi by 2. This with this red color. With this red color, I have shown this graph of sine of x between minus pi by 2 to pi by 2. According to our requirement, that was the requirement from minus pi by 2 to pi by 2. That was this. And then here is that line y equal to x. A line passing through region making an angle of pi by 4. So here is this line y equal to x. You can draw this line y equal to x. We can take 0, 0 point on it. We can take 1, 1 point on it. Even then, you may not think about the angle. 2 points are sufficient to draw a line. If this line passes through 0, 0, this line passes through 1 and 1. So we can have this line y equal to x. And now how you can get this graph? I have marked with green. I have marked it with green. So what I have done is I have folded the paper along this line. I have folded this paper along that line y equal to x. On that line y equal to x. Is it all right? And wherever you find red, you mark on the other side green. Other side green. Wherever red is on looking on this side, then on this side I have marked green. And if the red appears on this side, then I have marked green on this side. So wherever red is there on this side or on this side, then on the other hand I have marked green. So that is what? Now this red and green, they are coinciding. Red and green, they are coinciding. It doesn't appear 2 now. So it does not appear 2. Wherever was the red, I have marked green. So if that was there, I have marked green on this side. And now if I open up this paper, that gives you the graph of the inverse function. So that green one gives you the graph of the inverse function. This is not only for this function. Anywhere, any inverse function, if you know the graph of your original function, and you need the graph of the inverse function, then very simple device, that is draw this line y equal to x and then reflect it. And a very simple way to reflect it, I have reflected like this, mark that graph with red, and then the other side of the paper, whatever is there, this side, wherever red is appearing, I have put on the other side with green color. So that gives you the graph of your inverse function. So that's not only for this one, this is available for all. So don't take double labor, saving the labor that how to tackle with the graph of these inverse functions. Then for cos inverse, if really you want to learn these types of things, then we have to go through properly for the clear understanding. So here is this is pi, this is minus pi, this is pi by 2, and here is minus pi by 2 somewhere here, minus pi by 2. Now can you think about the graph of cos x? Have you seen the graph of cos x? What is cos of 0? 1. Cos 0 is 1. So it goes 1 on this side. Cos 0 is 1. And what is cos of pi by 2? 0. So it goes here. So that means this graph is giving you the shape like this. It's giving you the shape like this. It's 3 pi by 2 at this place and so on. So graph goes on like this. And again it is repeating after a gap of 2 pi. You can check up anywhere, it will repeat after a gap of 2 pi. Somewhere here it will be pi by 2. So you can start from here and notice it will repeat after a gap of 2 pi. Itself it will repeat. So again a periodic function we are having. So which portion we should select so that it becomes a 1, 1. Onto is very simple. And the range is already known, -1 to 1. So which part we should select so that it becomes 1, 1? Which part is the best? 0 to pi. See how the things are coming. It should come from within. It should come from within, how the things are happening. So 0 to pi is the best stable. Why to go towards the negative side? I can go towards the negative side. There is no problem. I can go from here to here. I can choose this part, minus pi to 0. I can choose minus pi to 0, but intention is normal, very clear intention that why to go towards wholly on the negative side, always move towards the positive side. So that means that this is the best way. The best way to choose is from 0 to pi, the values of x. X are to be selected from 0 to pi. Show me the page 3 again. Today's first page. So here is cos inverse. I have restricted the domain from 0 to pi. Domain and range they are going to interchange. Domain and range they are going to interchange for original function. For original function you have to restrict from 0 to pi. Is it right? So what is the domain of the original function? To make it as 1, 1. To make it as 1, 1, original function we are taking from 0 to pi. So range of course is -1 to 1. And now for the inverse. So what is cos inverse then? There was sine inverse. So here is cos inverse function. So this will become domain and here is the range, 0 to pi. Is it right? So think like that. That's a real way of thinking, proper way of thinking. This is how you are getting the things. Again, if you want to learn about a tangent inverse, so graph of tangent should be available. Unless that graph is not available, then the situation is just in darkness. So we'll be just working in darkness unless we know the situation of graph of tangent x. So should I have the graph of tangent x? Let me try to have that graph of tangent x. So here is the 0, and this pi by 2, and this is minus pi by 2. This is pi, and this is 3 pi by 2, and so on. So I am drawing a line here, vertical line. Vertical line. Vertical line is being drawn. You know tangent 0 is 0. And tangent of pi by 3 is root 3 greater than 1. And as it goes on increasing, it goes on increasing. So here, that type of situation, the graph is coming like this, moving. But it will never cross this line, never cross this line, because at pi by 2 it is not defined. At pi by 2 it is not defined. That type of situation. If you limit yourself less than pi by 2, it will remain on this side. And if you come to this side, then try to observe it. Then the graph will be like this. The graph will be in this way, that type of graph. So is this graph repeating? Repeating with after how much gap? Pi. Instead of 2 pi, this graph is repeating after a gap of pi. So this is a periodic function with period pi. So tangent and cotangent, they are with period pi, whereas the remaining 4 functions, they are with period 2 pi. So remaining 4 functions, they are with period 2 pi, but tangent and cotangent, they are only with period pi. So which portion I should select? The best portion. Point out that best portion to be selected, that it may be 1, 1. Best portion, very clear. There's not much burden on the mind. So minus pi by 2 to pi by 2, open interval. Because at pi by 2 it is not defined. So here that is a type of situation. And the range. So what is the domain for original? The domain for original is from minus pi by 2 to pi by 2. For original, this is the domain. For the original function, this is the domain. For the original function, what is the range? Range is R, all reals. Positive, negative, y, the values of y, all values of y. For this value of y, this value of y, for all values of y, that's there. So that means range is this one. So for original and for the inverse function, just reverse. So here become the range, that becomes the domain. This is the range and domain. Is that situation becoming clear? That what are these inverse trigonometric functions? So we are learning that practically, real situation we are learning. We are not just working in here. We understand that what is the meaning of these functions. Then other things I leave for you to realize. You can realize them provided the figures are before your eyes. The figures, they must be before your eyes. Only then you can, in fact, come out from within yourself that what should be taken as the domain, what should be taken as the range. So this is how we are thinking about the inverse functions. And then many properties. So here it is, sine inverse of x. They will balance. So here is a sine inverse working on sine. So if I call it as y, so if you want to go through a type of proof of these results, that is a type of situation I am writing. So here it is the first one. So sine inverse of x, I am writing y. So that means x will become sine of y. So x will become sine of y. Is it all right? Or can I write this x is equal to sine of y? What is the value of y? Y is equal to this much. So this I can write x is equal to sine of y. And here is y. Y is equal to sine inverse of x. So here we have proved really that sine inverse of x is equal to x itself. But here be very clear about this x. Be very clear about this x. This x is coming from which place? Its domain. The domain of sine inverse. Is it all right? And what is the domain of sine inverse? Domain of sine inverse is this. Domain of sine inverse is this. So mod of x less than equal to 1. What is the meaning of that mod x less than equal to 1? Minus 1 to 1. That's the way of writing. Instead of writing minus 1 to 1, I have absolutely no problem. If you want to write minus 1 to 1 closed interval, you can write as minus 1 to 1 closed interval. So here is cos inverse of x is equal to x. Again, if x belongs to this one. So this tangent inverse of x belongs to this. So all these results, they are available, right? So look upon this. So sine inverse of sine x. But here this x comes from which place? Observe the things. This x comes from where? Minus pi by 2 to pi by 2. So sometimes the people are so confused, they think that this is also x, this is also equal to x. They put that this is equal to this. That is definitely wrong. I have seen the papers of some schools, anyway, where they are saying like this. I wonder how they are saying like this. They say sine inverse of x is equal to, this is sine inverse of sine x. They say they are equal. Well, confusing altogether. Everything is confused. Everything is confused. It appears that we are getting x. They are thinking that this is equal to this. But they don't realize what is the situation. This is working only between minus 1 to 1. This is working for minus 1 to 1. Whereas this is working from minus pi by 2 to pi by 2. So they cannot be equal. They cannot be equal. One is working from minus 1 to 1. The other is working from minus pi by 2 to pi by 2. So no confusion should be there at all. We must be clear about their domain. And unless we are clear about their domains, so we can't go ahead. So move on. So here are few results for you. You will have to understand them instead of cramming only. Of course, you are required to know these results, some or other these results, but you try to understand them. Are you following it? What I am saying? Better to understand the situation. Once if we understand the situation, we are not confused altogether. Then we can make out what is happening. So mathematics is not only cramming, it is about learning, understanding. So here is sine inverse of minus x, that will become as minus sine inverse of x. If you want to have the proof, we can go through the proofs of such results. So here I am thinking about the first part. I want to demonstrate sine inverse of minus x is equal to, it is minus sine of x. So minus sine inverse of x. So how to go about the proof? So to go about the proof, let us call sine inverse of x, say, is equal to y. Either this or this, I am starting from here. I am calling this, say, as equal to y. Well, from here, can I say that this is x is equal to sine of y? Sine inverse of x is equal to y. I can definitely say x is equal to sine y. So what will be minus x? I need minus x. I need minus x is equal to minus sine of y. And this in trigonometry, we have already read it, that can be written as sine of minus y. Sine of minus y. Is it all right? And if it is so, then we can definitely write it as sine inverse of minus x is equal to minus y. And here is the value of y. Y is equal to sine inverse of x. So this is proved that this is equal to minus sine inverse of x. But something is missing in between. What is missing in between? The people don't understand, try to understand that. So here the situation is like that. You are writing after this step, you are writing this step. After this, you are writing this step. How you are allowed to write this step? Is there any justification to write this step? So we are writing inverse function. We are writing inverse function. From original function, from inverse function to write original, there was no problem. After all, original must be there, unless otherwise how we have created inverse. So original, there was no problem from this step to write this step. But this step is all right, this is again all right. But here, after this step, I am writing inverse function. So inverse function, when that inverse function is allowed, so this minus y, that should belong to what? For the inverse function. So what was there for the inverse function? One step back. Here was the situation. Inverse functions. So we should think about these inverse functions. So here it is sine inverse of x. So range is minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2. So that means here this y is varying from, this is y is varying from minus pi by 2 to pi by 2. Are you getting it? Sine inverse of x, I am calling it as y. So that means I am writing its value. And what is its value? That value is the range. That is x. The value, sine inverse of x. That is the value of sine inverse of x. So here is the value of range. So it is minus pi by 2 to pi by 2. But I need minus y. I need minus y. Can I multiply by a negative sign? If I multiply by a negative sign, so it gives you pi by 2 greater than equal to minus y and greater than equal to minus pi by 2. Or in other words, I can write minus pi by 2 less than equal to minus y less than equal to pi by 2. So minus y also satisfies this gap. If minus y satisfies this gap, inverse function is logical. Inverse function becomes logical. That is why we have written that step. I am pointing out what is behind these types of steps. Anyway, so these results are there with you. So many results I am leaving for you to decide about these results. I have written 2 pages. So this page as well as the next page, I see that all these results are available, known to you. So if you want to go through some proofs of few results, I have no problem. We can definitely go through the proofs of these results. But some few results, some of them, you must try to understand. Don't only cram. Only cramming is harmful, but cramming with some understanding, that makes meaningful learning. To make meaningful learning, so some work is required. So I am now taking up a few problems. So show me the next page. Here is your first question. The value of sine inverse of cos x, x belonging to 0 to pi is equal to the value of, this is sine inverse of cos x. Can I write it as pi by 2 minus cos inverse of cos x? Which result I am using? So I am using this result. So here it is sine inverse of x plus cos inverse of x is equal to pi by 2. Sine inverse of x plus cos inverse of x is equal to pi by 2. This is the result number 4. Result number 4, sine inverse of x plus cos inverse of x is equal to pi by 4. Can you go back? Show me page, this page number 3. Page 3. This is page 5. I need page 3. This is page 4. This is page 3. The question, this is number 3. So number 4. Sine inverse x plus cos inverse of x is equal to pi by 2. Sine inverse x plus cos inverse of x is equal to pi by 2. So here is sine inverse. Read this as x. So sine inverse of x. This I am reading it as x. Sine inverse of x is equal to pi by 2 minus cos inverse of x. Using this result 4. This term being taken to the other side. So sine inverse of x is equal to pi by 2 minus cos inverse of x. Sine inverse x plus cos inverse of x is equal to pi by 2. So I can say sine inverse of x is equal to pi by 2 minus cos inverse. So that is the result is being applied. Sine inverse of x is equal to pi by 2 minus cos inverse of x. Is it all right? Now here is cos inverse. So where is cos and cos inverse? Cos and cos inverse. Just a little back. Somewhat. First result. Look upon the first result. This is cos inverse. Cos inverse cos of x. Cos inverse cos of x. That is justified in 0 and pi only. Between 0 and pi. And in this problem, he has already mentioned between 0 to pi. So this is equal to pi by 2 and minus cos inverse of x. What is cos inverse of x? That is x. And this result is justified only between this gap. This gap is this result is justified only in this gap. So such situations you must realize that when this is justified, so that result was justified only in this gap. So this is equal to pi by 2 minus x. That was the first question. So wanted the answer to this question. Then question number 2. Question number 2, page. I have to refer to these formulas. Still, you are not aware of these formulas. You have not practiced these formulas. In fact, This inverse trigonometric function is your second chapter of class 12. Second chapter of class 12. You are still to go to class 12. So this is the second chapter. Anyway, they have given me this topic, which is the second chapter of class 12. So till now, you are not much aware of these types of results. So little problem. This is the first learning meeting across with these types of results. So what result we applied in this? We finally applied cos inverse of cos x is equal to pi. So two formulas we used. One was this formula used. The second was the other formula used. Directly, it was just the application of two formulas. So then here is the second question on page 5. Page 5. Are these pages available on your this is tablets as yet or not? Whatever I have done, not available as yet. So they will be available on your tablets. So today we shall have a little bit problem of that nature. Anyway, so I will be quoting the results. So here is the question number 2. Question number 2 is your range. Range is required for what? Sine of, range for, this is sine of sine inverse of x plus cos inverse of x. X understood mod of x less than equal to 1, because it must come from here. And for this must be less than equal to minus 1 to 1, lies between minus 1 to 1. So its range is required. Only one formula I need. So what is the value of sine inverse of x plus cos inverse of x? Pi by 2. That's all. In this formula, nothing much is required. So sine of pi by 2, sine of pi by 2 becomes 1. So what is the range? Range just consists of the single element. Range consists of the single element only. Very simple question. Now instead of this, sine inverse x plus cos inverse of x, if I say tangent inverse x plus cotangent inverse x, tangent inverse x plus cotangent inverse of x, well, that is also equal to pi by 2. But here, not change. That change is expected. This x must come from the domain, and that is R, all reals. Is it all right? And again, at this place, I can write cosecant inverse of x, cosecant inverse of x, and then secant inverse of x. Of course, that will be also equal to pi by 2. But in this case, x should come from which place? Yes, greater than equal to mod of x greater than equal to 1. So these types of situations, if they are not satisfying those type of things, then the problem is not meaningful. So see the problem, how the problem becomes meaningful. So question can be changed, but with a little bit modification. We have to modify the problem according to the situation. Here is question 8. Question 8 is sine inverse of x plus sine inverse of y is given to be equal to 2 pi by 3. Sine inverse of x plus sine inverse of y is given to be equal to this much. He says the value of cos inverse of x plus cos inverse of y. What is its value? That is the question. 4 choices, of course. We'll find out which one is the correct. So sine inverse of x plus cos inverse of y. So what is sine inverse of x? Can I write it as pi by 2 minus cos inverse of x? So from here I can write it as, this is sine inverse of x and plus sine inverse of y. I am writing it as pi by 2 minus cos inverse of x. And here I am writing it as pi by 2 minus cos inverse of y. So this is equal to, But what is this? This is given to be equal to pi by 3. So this is given to be equal to sine inverse of x plus sine inverse of y is given to be equal to 2 pi by 3. So 2 pi by 3 is equal to pi by 2 and plus pi by 2. Can I write pi and minus? So here it is cos inverse of x and plus cos inverse of y. I have collected these two terms with negative signs, collected these two terms with the negative signs, and then we are getting the value of this. So what will be the value of this cos inverse of x and plus cos inverse of y will be equal to this 2 pi by 3. So that is the correct choice. You can find out where it is written pi by 3. So again a simple question. I have gone through some simple problems. Anyway, before this I think we should have a little bit idea of what is sine inverse of 1 by 2. Can you find sine inverse of 1 by 2? What is sine inverse of 1 by 2? How to go through this? Can I write it as sine inverse of sine of pi by 6? What is sine of pi by 6? Is it 1 by 2? And now can I balance? Can I write it equal to pi by 6? Provided this x belongs to minus pi by 2 to pi by 2. Provided this belongs to minus pi by 2 to pi by 2. So you have to take care of that this is settled between minus pi by 2 to pi by 2. Unless it is settled in minus pi by 2 to pi by 2, we are not justified. So again, what will be sine inverse of minus root 3 by 2? Sine inverse minus root 3 by 2. The quick way is that I can write sine inverse of, this is a sine of pi by 3. Is it all right? But this negative sign still stands, minus. And you know this much, that we can write it as a sine inverse of sine of minus pi by 3. We know it's sine of minus x is equal to minus sine x. That much is known. And now, is that inner number, minus pi by 3, lies between minus pi by 2 to pi by 2? If it lies between minus pi by 2 to pi by 2, then logical to write. Otherwise, it will not be logical to write. Am I clear? That situation. So you will have to realize that what is happening. So what will be, say, is a cos inverse of minus, or there is another way out for this problem. What is the another way out? This was all right. Whatever I have done, that was a correct solution. There was no problem. You know what is sine inverse of minus x? And today we have read it, that this is equal to minus sine inverse of x. Minus sine inverse of x. That has been already read. Provided this is modulus of this is less than or equal to 1. Modulus of this is less than or equal to 1. That must be ensured. This must be modulus must be less than or equal to 1. This is there, and then now it becomes easy. So inside you can write sine of pi by 3. So that process is also open to you. There were two ways. So I could write sine inverse of sine of pi by 3. Sine inverse go, so minus pi by 3. This process, the earlier process, they are both equally good. We can go through any one. So what is cos inverse of minus 1 by 2? So either we have to settle inside. We have to settle inside, or we can apply a formulae. There is a formulae for this. What is cos inverse of minus x? Cos inverse of minus x, today we have read it, it is minus cos pi minus cos inverse of x. So we can settle the things in this form. If there is a negative sign in between, then see what result is available. So we know that this is pi minus cos inverse of x. So here I can write this as pi minus cos inverse 1 by 2. That's easy to settle. Pi minus cos inverse of, is it cos of pi by 3? Pi by 3, cos of pi by 3 is 1 by 2. Cos inverse, they will cancel, provided this lies between 0 to pi. And this is there between 0 to pi, so there is no problem. So it is pi minus pi by 3. That's 2 pi by 3. 2 pi by 3. Is it all right? Or the other way may be the alternative. We can think like this: cos inverse of minus 1 by 2. You can think of cos inverse of cos of 2 pi by 3. Or I can think of, yes, cos inverse cos of 2 pi by 3. What is cos of 2 pi by 3? Is it minus 1 by 2? Is it minus 1 by 2? And does it lie between 0 to pi? This number must be between 0 to pi. Only then justified. Otherwise, a mistake. Otherwise, a mistake. So this will be equal to 2 pi by 3. So that was all right. This is also all right, provided you understand it. So which process you follow, it doesn't matter. But I would prefer to take negatives out. If they are there, I like to take negatives out, take inside positive, that's easy to write. But use the proper results. And whenever you write, so be very clear about the situations. So what will be sine inverse of sine of, say, 5 pi by 3? Don't think that you can cancel out like this. 5 pi by 3. You can't write 5 pi by 3. That is generally the intention. You write it as 5 pi by 3. And this you can write provided it lies between minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2. So you have to do little bit labor. Don't write blindly. You will have to see the situation. This is justified to balance, provided it is between minus pi by 2 to pi by 2. So it is not there, so we'll have to settle it. So how to settle it? So we can think about the sine inverse of sine of 2 pi minus pi by 3. 5 pi by 3. 5 pi by 3, I'm writing it as 2 pi minus pi by 3. Is it all right? And any formula for this? What is this? Sine inverse sine of minus pi by 3. Or you can write like this. I think you are aware of this result. Sine of pi by 3. You are aware of this result. Is it right? Now you can take negative in. Now you can take negative in. So here it is sine inverse of sine of minus pi by 3. So what is the final result? Is minus pi by 3, not 5 pi by 3. So be very clear about these types of mistakes. So what is cos inverse of cos of 7 pi by 6? Give me the answer. Finally, whenever you balance, it should lie between 0 to pi. So that thing has to be taken care of. Can I write cos inverse cos of say pi plus pi by 6? We can settle it in many ways. And this is equal to cos inverse of minus cos of pi by 6. Is it right? How you can take negative out? Pi minus, agreed. It's pi minus cos inverse of cos of pi by 6. So here it is pi minus pi by 6. Is it right? Or can I quote another way out? So here one can think even in this manner, cos of 2 pi and minus 5 pi by 6. That was also there. There was no problem in thinking like this. Is it right? So what will be this? This is equal to cos inverse of cos of 2 pi minus x, cos of minus pi by 6. But cos of minus x is equal to cos of x. And this is equal to 5 pi by 6. Earlier, I think also, what was the result obtained in that manner? 5 pi by 6. So see, we can work out in any way. But finally, you have to settle the things between 0 to pi. So that type of situation, finally, you have to realize. Only then we can work out. Here is sine of cotangent inverse, cotangent of 17 pi by 3. So in fact, we have to settle here. The sine is simple. The main problem is about this. 17 pi by 3. And we are talking about cotangent. So ultimately, for the cotangent, what should happen? For cotangent, 0 to pi. For cotangent is 0 to pi. For tangent is minus pi by 2 to pi by 2. So all those things to be seen properly when how the things are settled. For cotangent, it is 0 to pi. So we have to settle it somehow or other by any calculation to be settled between 0 to pi. So how you can settle it between 0 to pi? So can I write it as a sine of cotangent inverse cotangent of 6 pi minus pi by 3? Is it right? 6 pi minus cotangent 6 pi minus pi by 3. Is it all right? And this will be what? So this will be sine of cotangent inverse cotangent of what? Minus pi by 3. So here is minus cotangent of pi by 3. So this is equal to sine of cotangent inverse, then minus, can I write cotangent of pi and minus 2 pi by 3? What would be this much? Cotangent, and here is a negative sign. Pi by 3, I am writing as pi minus 2 pi by 3. So what will be this? Minus cotangent. Minus, minus, that will balance. So here it will be sine of cotangent inverse and cotangent of 2 pi by 3. Cotangent inverse, they are balanced. This is between 0 to 2 pi. There is no problem. So finally, we are left with sine of 2 pi by 3. What is sine of 2 pi by 3? If there is any problem, you can write pi minus like that. You can settle it. Don't be fussy. Don't create mistake. One step extra may be written, does not matter. Root 3 by 2, positive. Root 3 by 2, positive. So this is how we can go about these types of questions. Then I am taking up a question from this material. This question 6, which I have written. So this does not appear in your Udaan, but this is a question from IIT papers. So sometimes back. So, this question number 6 is sine inverse cos of it is 33 cos of 33 pi by 5. Now here it is a sine inverse, there is cos. In all these problems I was writing the same. I was writing the same signs and sine inverse like that, cos inverse. But there is a change here. So inside, in place of sine, otherwise we should have got sine. Unless we get sine, it can't be balanced. We are to balance ultimately. We are to see that how it is to be settled. So ultimately, we are to convert it in the form of sine. Only then the situation will settle. First of all, this is a bigger number. So we are to settle it in a proper manner. So sine inverse cos of, I think I can write 6 pi and plus 3 pi by 5. Is it all right? And then 6 pi, that goes in rounds. So that means it is a sine inverse of cos of 3 pi by 5. Cos of 3 pi by 5. Up to this step, it was easy, I think. There was not much problem. But now, somehow or other, we want to bring sine. We want to bring sine at this place. That is our necessity. That's our necessity. How to bring sine at this place. So how you can think of to bringing sine at this place? Can I write sine inverse of so here it is cos of pi by 2 and plus, if I write cos plus, it will be finally in the shape of sine. So what is cos of pi by 2 plus how much I am to write? 3 pi by 5. So what else I am to write to settle it? Should I write pi by 10? Check it. What is pi by 2 and plus pi by 10? 3 pi by 5. If there is any problem, you can do the things like this. 3 pi by 5 minus pi by 2. 3 pi by 5 minus pi by 2, what number is left? So in that way we can settle. So this is further equal to, sine inverse of, what is this result? Minus. So yes, minus sine of pi by 10. Is it all right? And then negative must go in. Negative, that must go in. So that means it is a sine inverse of sine of minus pi by 10. And it is between minus pi by 2 to pi by 2. Between minus pi by 2 to pi by 2. So we can settle now. So what is the final result? Minus pi by 10. There are 4 choices. So we can find out which one. Sometimes more than one choices are also correct. Anyway, this is just one answer. So only one choice will be correct. So here is question number 7, again from your competition papers. So this question is cos inverse of sine of 10 pi by 7. Now it says find its principal value. Even if this word principal is not mentioned, understood that we are working only for the principal values. Taken for granted that we are working for the principal values. Again, there is a little bit trouble. Inside it is a sine. We have to settle it in the form of cos, because earlier we can't change that cos inverse. That is not possible to change. Inner we can settle the things. So inner we can settle the things. So how to settle the things? Inside. So I can write cos inverse of sine of, I have to write pi by 2 because I want to change it to cos. Ultimately, to change it cos, I have to write it as pi by 2 plus or pi by 2 minus, something like that. It is all to be seen that how we can settle it, but after all, it is to be settled. So what else? Out of 10 pi by 7, you subtract pi by 2 and see what number is left. Out of 10 pi by 7, you subtract pi by 2 and find out what is left. And do this calculation. 7 pi by 10 minus pi by 2. 7 pi by 10 minus pi by 2. Do this calculation. What is the problem in doing this calculation? Yes? Pi by 5. Ten pi by 7 minus pi by 2, LCM is 14. So here it is 10 and minus 5. No, it's not 10, it's 20 minus 7 pi. You are giving me a wrong result. Are you not giving me a wrong result? So it is 13 pi by 14. So what we should write at this place is this number, plus 13 pi by 14. This is equal to, so what is sine of pi by 2 plus x? Sine of pi by 2 plus x, cos x, not minus cos x. Pi by 2 plus x, sine of pi by 2 plus x. Don't think what is x, whatever it is. So it is pi by 2 plus x. It is your cos of x. So here we are getting it as cos inverse of cos of x, 13 pi by 14. And does it lie between minus pi 0 to pi? It should be between 0 to pi, only then to settle. Otherwise, some more adjustment might be needed. We might require some more adjustment, but if it is already between 0 to pi, so things are settled. So that means the answer finally turns out to be 13 pi by 14. So that is the answer to this problem. This is the first, your first exposure with this class 12, chapter 2. So don't be afraid of. You are just starting with this chapter. And even with a mixed type of questions we are having, some simple and some little bit difficult as well. So here is question number 9, that sine inverse of 1 by 5, sine inverse 1 by 5 plus cos inverse of x is equal to 1. And he demands the value of x. The value of x is required. We are given this much. Sine of sine inverse 1 by 5 plus cos inverse of x is equal to 1. the value of x is required. So here is sine. I am writing it as sine inverse of 1 by 5 plus this is cos inverse of x is equal to sine inverse of minus 1. Here is sine. This sine taken now to the other shape, sine inverse 1. What is sine inverse 1? Can you give me the value of sine inverse 1? We have done so many questions. Pi by 2. So sine inverse of sine of pi by 2. Sine of pi by 2. So we'll be getting as pi by 2. So this is further equal to, so here what we have obtained is sine inverse of 1 by 5 plus cos inverse of x is equal to pi by 2. Is it right? Or can I write cos inverse of x is equal to pi by 2 minus sine inverse 1 by 5? Is it this equal to your cos inverse of 1 by 5? Pi by 2 minus sine inverse of x. It is cos inverse. We know this much. Sine inverse of x plus cos inverse of x is equal to pi by 2. I think the value of x is available. Cos inverse. We can take cos of both sides. We can take cos of both sides. So cos inverse balanced. And ultimately we'll be getting x equal to 1 by 5. Even directly from here, there is no trouble in thinking of that this x is equal to 1 by 5. So if we plan the question properly, then there is no problem. If we don't plan it, then there is a problem. So here is question number 10, and that is 4 sine inverse of x plus cos inverse of x is equal to pi. This is given. 4 sine inverse of x plus cos inverse of x is equal to pi. And he demands the value of x. What can be done? Can you suggest me any alternative? Anything for this question? No, here is a cos inverse. You convert it in terms of sine. So pi by 2 minus sine inverse x. Okay? Or you can do, that is one sine inverse may be taken along with it. Leave 3 sine inverse there at that place and take 1 sine inverse along with this. Is it all right? That is also a way out. Or directly you can convert this cos inverse to sine inverse. I can rewrite it as 3 sine inverse of x, and plus I can think of sine inverse of x and plus cos inverse of x, and equal to pi. So that will give you pi by 2. Is it right? So that is a way. Otherwise there was no problem. Here I could directly write pi by 2 and minus sine inverse. Ultimately we shall be reaching at the same place. So here this gives you pi by 2. So that means finally I have saved one step here at this place. So we find as 3 sine inverse of x is equal to pi and minus pi by 2. Pi by 2. Is it right? We can divide by 3. So that gives you sine inverse of x is equal to pi by 6. So what is x? Simple. So x is equal to sine of pi by 6. You know what is sine of pi by 6? So here is the answer to this problem. So here is a question, 11th question from your Udaan material, a good question, simple and a good question. So here is a is less than equal to tangent inverse of x plus cotangent inverse of x plus sine inverse of x is less than equal to b. Less than equal to b. Then he is writing 4 alternatives. Then he is saying that a may be equal to 0. 11th question. First part he is writing A part he is writing that this A may be equal to pi by 4. B part he is writing A may be 0. And C part he is writing B is equal to pi by 2. And D part he is writing as B is equal to pi. So how this question can be settled? Any suggestion? This is simple. Tangent inverse x plus cotangent inverse x. At least we can simplify the problem. So we have started simplifying the question. So here it is. So that means this implies that A is less than or equal to pi by 2, and plus we are left with sine inverse of x, and it's less than or equal to p. What is the value of sine inverse of x? Lies between what to what? Sine inverse of x. Range. You are right. Is the range, not x. X lies between -1 to 1. But sine inverse of x lies between minus pi by 2 to pi by 2. So here that much is known. We already know this result, that minus pi by 2 is less than or equal to sine inverse of x is less than or equal to pi by 2. This much is known to us. It all depends upon your this technique. First of all, tangent inverse plus cotangent inverse, that was simple. So finally, really question depends upon your this way of thinking, that the sine inverse of x lies between minus pi by 2 to pi by 2. Now what we need the value of pi by 2 and plus sine inverse x. We need the value of this expression. That means how you can, from here to here, how you can go to that? We have to add pi by 2. I am adding pi by 2. If I add pi by 2 on this side, so I am getting as pi by 2 plus sine inverse of x and less than or equal to pi. Is it all right? And now you can compare this question with your given problem. See what is this. So this A is all this. I have simplified this one. What I have done is I have simplified this. What is the meaning of this? The meaning of this is your this expression. The meaning of this is your this expression. Is it all right? So it is A less than or equal to B. So here it is 0 is less than or equal to this. So what value of A can be expected? 0. So that's the correct choice. A is equal to 0. A is equal to pi by 4 is wrong. Okay? And then B is what? Pi. So there are two correct choices. There are two correct choices. One is this correct choice. The other is this correct choice. I think simple. One can understand it, that this is a type of situation. This merging out of this. And yesterday I told you that this is inverse trigonometric functions in particular is a very high scoring area. There are certain parts which are high scoring areas, and this inverse trigonometric functions. And the students who go to these competitions really get good marks. There are certain areas where generally the people are lacking. And some the people who score in these types of areas, they excel. There are certain areas where all type of students, they score. Some areas are there where all type of students score, but there are certain areas where the few students, they score. And the students who score in these types of areas, well, then naturally they go up. And whatever I will be doing with you, I'll try to select these types of areas where generally are some troubles, something is needed from the brain itself, not only the mechanical work. One is a type of mechanical work. Questions can be done. Of course, I do not mean that other topics they should be ignored, not at all. They're not to be ignored, but there are certain areas where one has to excel. And this is one of them. Then another question from competition. Really, the question is of the same nature. So here is question number 12. Question number 12 is like this. This k, small k is written in place of a. Here it is sine inverse of x and plus cos inverse of x and plus tangent inverse of x. Plus tangent inverse of x is less than or equal to capital K. The similar situation. There's not much change in this problem. So similar type of situation is there. Then he is giving you the four choices. Four choices they are needed. So we shall find out what choice is required. So this question number 12. I am not writing those four choices. I am trying to solve the problem. So first of all, we should be clear about this. What is this? Sine inverse x plus cos inverse of x. That's simple. So that means it follows that this k is less than or equal to pi by 2 and plus this is tangent inverse of x is less than or equal to capital K. Now, you know what is tangent inverse of x? The whole thing depends upon your this thing. Tangent inverse of x, range, not the domain. Domain of tangent inverse x is all reals. All reals. The range is minus pi by 2 to pi by 2 open interval. Minus pi by 2 to pi by 2 open interval. So we know this much. Minus pi by 2 is less than or less than, not equal to. We can't write equal to here. Tangent inverse, that is not defined at pi by 2. This is the open interval. So this less than tangent inverse of x is less than pi by 2. So what can be done? Pi by 2 to be added. So here it is 0 is less than pi by 2 plus tangent inverse of x less than pi. And he is giving you four choices. Out of one choice, he says k is equal to 0, capital K is equal to pi. Both together, small k and capital K, then b equal to b choice. I think this is a correct choice. This is a correct choice. Small k, well, that can be 0, less than or equal to 0. And on the other side, that's pi. So k is equal to pi. So A is definitely one of these choices. The other choices we can find out whether they are settled or not. Really, in this case, the other choices, they are not settled. The second choice he is giving you, k is equal to 0, and then this capital K is equal to pi by 2. Well, this is all right, but that is a interval. So that means this goes. Then the third, whatever he is saying is, third choice is small k is equal to pi by 2, and capital K is equal to pi. Capital K, pi is all right, but we are interval. Here he is giving these two values simultaneously. Small k is this and capital K is equal to this. This is again violated. And D, he says none of these. So that's simple. So only that means A was the correct choice. So again a question from competition papers. Your next question is tangent inverse of tangent of minus 6. This is from your Udaan material, question number 13. And there are four choices. The choices are, the A choice is minus 6, B choice is pi minus 6, pi minus 6, C choice is 2 pi minus 6, and D is none of these. None of these. So which one is correct? Can you balance tangent, inverse, and tangent or not? We are getting -6. Does it lie between minus pi by 2 to pi by 2? Does it lie between minus pi by 2 to pi by 2 or not? What is minus pi by 2? Approximately minus 1.5. Okay? Are you getting it? And pi by 2 is approximately 1.5. And here we are getting -6. So we are to settle it. We are to settle it in such a manner that we come with a number which lies between minus pi by 2 to pi by 2. Is it right? So that thing is main to be observed. So here if I think about this number 2 pi minus 6, 2 pi minus 6, I'm thinking about this number 2 pi minus 6. What is this approximately? 2 pi minus 6. 2 pi minus 6. How much? Little positive number? 0.28, something like that, 0.28, 0.28 positive. And does it lie between minus pi by 2 to pi by 2? It does. So things will be settled. Are you getting the idea behind it? The main question he has given for this purpose. And 2 pi minus 6 is among one of choice also. So it appears the things will settle down. It belongs to this gap. First observation. That's very much needed. This 2 pi minus 6 belongs to this gap. So we have to try this problem to settle like that. So what will be tangent of 2 pi minus 6? Let me settle this much alone. Then finally I shall settle at that place. Let me find out what is tangent of 2 pi minus 6. What is this? Yes, come on, come on. If it is wrong, then what's the problem? I don't mind if it is wrong, we'll correct it. Tangent of 2 pi minus 6 is equal to minus tangent of x. So it is minus tangent of x. And this I can write tangent of minus 6. Because tangent of minus tangent x is equal to tangent of minus x. So that means this is settled. So here is tangent inverse of minus 6. That can be settled like this. We have already settled. Therefore, now we can say what is tangent inverse tangent of minus 6. I can write it as tangent inverse of tangent 2 pi minus 6. And this 2 pi minus 6 definitely belongs to this gap. Because I have proved this result that tangent of 2 pi minus 6 is equal to tangent of minus 6. I need tangent of minus 6. I need tangent of minus 6. So here is tangent of minus 6 already settled in that form. So this is already settled there. So this is equal to what? 2 pi minus 6. So naturally, this choice is a correct one. And from this question, you must observe, he is talking about numbers. He is not talking about angles. And there should not be any confusion. Really, we are working on numbers. A domain, range, whatever we are talking about, we are working on numbers. So trigonometry is on numbers, not on angles. If we come across a problem on triangle, some or other, if we come across with a problem on triangle, then we shall think about trigonometrical ratios. But here we are working in general, and general trigonometry is on numbers. So here it is cos inverse of cos of 12 and minus sine inverse of sine of 12. And the value of this is required. Says the value of this expression, whatever is this. Instead of 1, there are two things now to be calculated. One is cos inverse of cos of 12 is required. The other is sine inverse of sine of 12 is required. Two things are required. And then finally, to be settled. So let us see how you try it. Can you try it now? I have settled 6. Now you try to settle this 12. Try to settle 12. So what is 4 pi minus 12? What is 4 pi minus 12? How much? Does it belong to 0 to pi? I need it to be between 0 to pi, not from minus pi by 2 to pi by 2. We are working for cos. And for cos, I need between 0 to pi. And it is there between 0 to pi. This definitely belongs to 0 to pi. So the things may be settled. So let me find out what is cos of 4 pi minus 12. What is cos of 4 pi minus 12? So is it cos of minus 12? Cos of 4 minus 12, it is cos of minus 12. Cos of 4 pi minus 2 pi, and then again 2 pi, another round. And cos of minus 12 is equal to cos of 12. I think this step we have cleared. This much part we have cleared. Therefore, I can say that cos inverse of cos of 12. So I can say it cos inverse of cos of 4 pi minus 12. And this is equal to 4 pi minus 12. So half of the question I have cleared. Now come to the other half. So here is sine of 12. So what is sine of, what is minus 4 pi plus 12? How much? Does it belong to minus pi by 2 to pi by 2? Minus pi by 2 to pi by 2. Of course, it is towards negative, but it definitely belongs to minus pi by 2 to pi by 2. So the things will be settled. We are working for sine. So if it belongs to minus pi by 2 to pi by 2, the things will be settled. Is it right? So now you find what is sine of minus 4 pi and plus 12. What is sine of this? No, sine of 2n pi plus x. Sine of, you know this is it. Sine of 2n pi plus x is equal to sine of x, where n is any integer. N may be any integer. And here n is minus 2. N is equal to minus 2. Is it all right? So n we find is minus 2. So I can directly use this result. If I directly use this result, I can say straightway that it is sine of 12. Instead of creating a trouble of negative, one negative, then again negative, we shall have to settle it. So in that manner, but we have settled it in one step. In one step, we have settled it. So we find that this is equal to sine of 12. And if it is so, then what is the sine inverse of sine of 12? From here, I can write it as sine inverse of minus 4 pi plus 12. Sine, I have not written sine. Sine inverse, then this is sine of minus 4 pi plus 12. And this is a number which belongs to minus pi by 2 to pi by 2. So we are justifying writing minus 4 pi plus 12. So I have obtained the value of both parts, the value of this part, the value of this part. So what is the value of this part? The value of this part was 4 pi minus 12. And what is this minus? The value of this part is minus 4 pi plus 12. So what is the final answer? 8 pi minus 24. 8 pi minus 24. So there are 4 choices. Out of these 4 choices, you can locate this choice, 8 pi minus 24. That is the correct choice. So here the next question is sine inverse of sine of phi. Phi, this is phi written here, is greater than, given to be greater than x squared minus 4x. The complete set of solutions, there is an inequality, so there must be set of solutions. He says the complete set of solutions of this inequality is, so 4 choices are being given. Here the choices are like that. A part, x minus 2 mod is less than 9 minus 2 pi under root. He is writing like this. 1 choice, anyway, 4 choices. So we are to solve the question and we are to find out which choice is the correct one. The main problem is this. As there we were settling minus 6, we have settled that is your 12, and now here the problem is to settle phi. So how to settle phi? Try to settle phi. Phi is to be settled. What is minus 2 pi plus phi? What is minus 2 pi plus 5? Approximately how much? Does it lie between minus pi by 2 to pi by 2? It lies between minus pi by 2 to pi by 2. Am I right? So minus 2 pi and plus 5 is minus 6.28 like this, and plus 5, so minus 1.28, and what is minus pi by 2 is minus 1.5, so it is definitely there in this gap. So that is the main thing to be observed. So here we find it that this belongs to minus pi by 2 to pi by 2. This belongs to this gap. So what is now? So sine of minus 2 pi plus 5. What is this? This is n pi. N is 1, 2n pi. I have written it like this, 2n pi plus 5. I have saved 1 or 2 steps in between. Otherwise, we might have settled 2 pi minus 5, then again negative. But here is a minus 2n pi. So that means it is sine of 5. Directly we find that it is sine pi. So now look upon the question. The question is sine inverse of sine of 5 is greater than x square minus 4x. Is it all right? So that means the sine inverse of, what is sine of 5? Sine of 5 is equal to this much. Am I right? So that means it is sine of minus 2 pi plus 5. And it is greater than x square minus 4x. So this implies what? So we are left with minus 2 pi plus 5 is greater than x square minus 4x. Or I can write x square minus 4x is less than minus 2 pi and plus 5. I want to complete the squares. To complete the squares, what else is required? 4. So here I am writing it as x minus 2 whole square, saving a step. So 4, practically I have added 4 on this side. So I have to add 4 on this side, adding 4 on this side. So it will give you 9 minus 2 pi. I've added 4 to both sides. Added 4 to both sides. Is it right? Or can I write this as, this implies x minus 2 mod whole square. You know what is x modulus whole square? It is equal to x square. X modulus whole square is equal to x square. What is x modulus? Either it is plus x or minus x, and we are squaring. We are squaring, so there is no problem. So here is x minus 2 modulus, because he demands the answer in the form of modulus. And this is less than 9 minus 2 pi. So that means this is x minus 2 modulus. I am taking under root. And now negative sign should not appear, because modulus is positive. Modulus is positive. You can't write plus minus. Otherwise, if it is not modulus, we might have written plus minus. That type of situation might be there. But here, no trouble of that nature, because this is modulus. Modulus can never be negative. So only plus. So that means here is, this is only 9 minus 2 pi under root. So I have written only that choice, which was the correct one. The other choices, they are not the correct one. Is it, time is over? Or still? Only 7 minutes more. Oh. Any question online? No question online. The students have stopped asking me the questions. Huh? Which question number? If they are asking a question, let me find out which question they are asking. But I have gone up to in question number 5 on functions. So I will need at least one more session, rather 2 sessions I will require for functions. If I am to deal with the functions properly, I hope so. Cbse will be kind enough to give me 2 more sessions. So then I will be able to answer that question 5. That was the question which I gave yesterday, I think. The question which I gave yesterday. And for that, we need much more knowledge. Much more knowledge is required on that functions. So today or yesterday, whatever I have done is, I have done only that part of the functions which may lead us to inverse trigonometric functions. Otherwise, enough is left in functions. Don't think that we have done functions, and just we have touched functions. We have touched functions, and I have taken specially to that stage where I can touch this topic on inverse trigonometric functions. So my main concern was that how to bring to you on these inverse functions. What are inverse functions? And yesterday about functions, we talked only like that. What are the functions? Some idea about functions, domain and range, and then of course taking to that stage, that how we can go through these 1 function on 2 functions so that we can have inverse functions. Enough is left in functions, so enough time will be needed for that. So I shall be answering in my after break whatever we got. Their question, this question they are asking. Oh, I have answered already the problem. The sine inverse cotangent of 17 pi by 3. Have we solved it today? Check it. We have solved it. So why they are asking again then? This question number 5 has been already solved. And this root 3. And if there is a problem, I can repeat. Now here is a 17 by 3, that is pi, 17 pi by 3. This has to be settled between 0 to pi. This has to be settled between 0 to pi. Cotangent inverse, that is possible. Cotangent inverse and cotangent, they will go. Of course, they will go. How they will go? I have not explained to you that really how they have gone. It needs the idea of composite functions. I have not given you the idea of composite function at all. Anyway, when I get the sessions, I'll give you the idea of composite functions, that how they go. Don't think that they balance like this. They are not the situation like this. More depth is required. Much more depth is required that they are balancing and how they are balancing. So we shall go through that situation. But here was a cotangent of 17 pi by 3. That was to be balanced. So how it is to be balanced? I think if you want, I can repeat that question. It is just a matter of repeating. So it is cotangent of 17 pi by 3. I could write it as a cotangent of 6 pi minus pi by 3. Is it right? And this is a 6 pi, 3 pi that goes in round, and we will be finally left with minus cotangent of pi by 3. Minus cotangent of pi by 3. And that minus cotangent of pi by 3, we can further write it as cotangent of pi minus 2 pi by 3. You can settle it. See what you are getting. So minus, and then again settle it. It becomes a minus minus. So here is cotangent of 2 pi by 3. Cotangent of 2 pi by 3. And now here we are getting as cotangent of 2 pi by 3. So finally the situation is sine of cotangent inverse cotangent of 17 pi by 3. In place of that, we have got as cotangent of 2 pi by 3. So this is equal to sine of cotangent inverse. So we are left with 2 pi by 3. And what is sine of 2 pi by 3? Is root 3 by 2. Sine of 2 pi by 3 is root 3 by 2. That A option was the correct. Yes? Why is 0 not the answer of question 14? I have gone through. This is that whatever working may be there in between, that may not lie between minus pi by 2 to pi by 2. Ultimately, we are to settle the situations between minus pi by 2 to pi by 2. If it is settled between minus pi by 2 to pi by 2, and then if you get the answer as 0, I have no objection, provided the things are settled between minus pi by 2 to pi by 2. So I have written this just from the Udaan material. I will check again whether this is possible or not. So if it is possible to settle it between minus pi by 2 to pi by 2, and in that way finally you get the answer as 0, then I will mark 2 correct choices. Then instead of 1 correct choice, I will mark 2 correct choices. That might be there. 2 correct choices might be there. But one has to be sure that whatever you are writing, that lies between minus pi by 2 to pi by 2. So that has to be taken care of. Again, I am speaking again. Well, for the inverse trigonometric functions, I will be coming back to you. For the functions, I will be coming back to you. For these inverse trigonometric functions, I will be coming back to you whenever CBSE calls me, gives me the time. So they have assured me to give me the time. If they want to give some justice to the topic, then naturally more time is required. I hope so. They have, in principle, they have already agreed to that. So I hope so. They'll agree to that. But in the meantime, I would advise every one student online that please prepare my these two chapters earlier done, permutation combinations, and this is trigonometric functions, inverse trigonometric functions, and whatever little I have done yesterday and today. I have done very little on yesterday, very little today, not much justification to functions and inverse trigonometric functions. Little bit touched, of course. I have touched functions. I have touched this inverse trigonometric functions, but more time will be devoted on these functions, trigonometric functions, inverse. And today I am not going to give you the solutions of all this. Of course, the solutions are with me. So solutions I will be providing to you of all the questions after the break when we discuss all these things. First, I want to discuss it, and then some questions. If they are left, I will be providing you the solutions. So on that permutation combinations and trigonometric, I have provided the solutions. Please look upon the video, see your material, and prepare these chapters well. Very good scoring areas. Permutation combination is also a scoring area. Trigonometric functions, trigonometric equations is a scoring area. And inverse trigonometric functions gives you little up, brings you up than the average one. So thank you very much. Time is over, I think. So thank you very much. I think you
नहीं शकल नहीं दिख रहा, अनलॉक कर रहा था, अनलॉक करके यस बहुत सारे बच्चे आ गए। हेलो, लास्ट टाइम वाला रिपीट नहीं करना है ना? यस, बोलो बोलो। We have done almost all the way. We're not there last time. I couldn't find any sadness on your face. Everybody is happy whether you're there or not. So, good afternoon, everyone, as well as the children across the other centers. We are once again today going to do waves, the remaining part of the waves. Basically, two important topics left out, beats and Doppler effect. However, while doing beats and Doppler effect, I will not mind at all if you ask certain things which we have covered last time. Fine, but I will be confining on beats and Doppler effects. So let's begin with beats. There's hardly difference in spelling of the beat when you use this word when somebody is beating someone and this beat. Okay, if a child is beaten by a physics teacher in a classroom, same beat we use. So there should be a clear-cut meaning of beat therefore in your mind. What is beat? And I wonder that whether you have been beaten by your teacher ever. If ever, then probably they give slaps one after another, you know, a chart, fit chart, something like this. So that is where we get the meaning of beat. No teacher comes and beat you like this. एक चाटा लगाया और लगा के ऐसे पकड़ के ही रखा है. Okay, they are supposed to be putting the hands away and bringing it again with some force. So this frequent movement of hands, that is giving us the meaning of beat. Okay, so something which is occurring with certain frequency could be called beat. And that is why the drum beat, you know, word drum beat. Again, in drum beat, you know, we hit the drum and we keep on hitting with certain frequency. It's not that we hit once and then we'll celebrate forever. No. So what is beat? We can define beat as a, let us have a technical term also when you understand beat, because it is not all about frequency. Certain things in this nature, they are actually beyond our human range, whether it's the audible range or the visual range. For example, after certain wavelengths, we can't see. Okay. And I wonder that the wavelength which we see, they are so small as compared to the total range of the wavelength of electromagnetic wave. Only 400 to 764 nanometers, something which we can see. Rest of the wavelength we can never see. Similarly, certain frequency of sound we can always hear, but rest we can't hear. Okay. And last time I told you that what we hear as an audible range, apart from that range, there is another frequency criteria which we need to understand, which we call the persistence of our audible limit, or auditory system, like persistence of vision. Remember, I told you that if we have got two sounds and these two sounds are appearing to us in less than 0.1 second, then you will never be able to bifurcate these two sounds as two different sounds, as if you will listen them in spite of there being two different sounds, as if you listen them as a single sound. So you're able to hear me, you're able to bifurcate my words because I'm cleverly maintaining that gap of time duration, 0.1 second. जल्दी जल्दी बोले अगर आप कहोगे सर क्या दोबारा, जैसे क्लास में कभी कुछ टीचर जल्दी बोलते हैं तो आप अक्सर बोलते हैं मैम दोबारा बोलिएगा समझ में नहीं आया, something like that, because you're not able to bifurcate those two sounds which are appearing for less than 0.1 second. And if you reciprocate this 0.1 second, you get how much hertz? 10 hertz. Very simple therefore to understand कि अगर 10 hertz frequency difference से ज़्यादा difference if two sources they have, then these two sources might generate certain repeated frequency process, but you're not able to bifurcate them. Okay. Therefore, if you derive, first of all, what is beats then? Finally, it's a waxing and waning of sound. Or I can also say rise or fall of sound. Rise or fall, rise and fall of sound. When two or more, let's make it two only, it will be difficult otherwise, two sources produces sound, they produce sound together. In the same medium. Okay, for example, if one source produces a sound of frequency, say N1, source 1, other source produces a sound of frequency N2. Okay, I can prove that the beat frequency is given as N1 minus N2, where this sign means the difference from the bigger value to the smaller value. Okay, you can write this way as well, where N is the beat frequency. Not to mention here, it should be very clearly understood by all of you that in order to appreciate the beat being generated, I mean in order to listen the beat being generated, it is important that this beat frequency N should be less or equal to how much? 10 hertz. I'm not saying if it is more than 10 hertz, beat will not be generated. It will be generated, but for us as a human being, sorry, we will not able to bifurcate them. Maybe bats are going to bifurcate them. Maybe other animals are going to bifurcate them. Okay? Is that okay? Proof? नहीं चाहिए ना? Proof की जरूरत नहीं है. Let's straight away then try to understand problems which are asked in the beat, in the cases where the beat. Now there are sources like tuning fork. Even I am a source, you're also a source. Horn of a vehicle. Okay? Whistle of a policeman. Wherever sources are there which generate sounds, every source has got a particular frequency. Okay, and that frequency should not be confused by you from the intensity. For example, a police wala might whistle very slowly. Okay, but the same whistle he might whistle very loudly. Now, since the whistle remains same, what will remain same? Frequency will remain same. Intensity will differ. ठीक है, जैसे मैं अभी बात कर रहा हूं, कभी तेज हो जा रहा हूं, कभी स्लो हो जा रहा हूं, मेरी फ्रीक्वेंसी नहीं बदल रही, क्योंकि वो मेरे वोकल कॉर्ड की एक इनहेरेंट एबिलिटी है. भगवान ने जो दिया है मुझे स्वर, मैं उसी स्वर में बात करूंगा, सर उसी स्वर में बात करेंगे. फ्रीक्वेंसी आप उसी स्वर में बात, लेकिन मैं कभी तेज हो जा रहा हूं, कभी स्लो, मतलब इंटेंसिटी में वेरी कर रहा हूं. ठीक है, तो वी आर नॉट एट ऑल कंसर्न हियर विद द इंटेंसिटी, वी आर कंसर्न ओनली विद द frequency. ठीक है, क्लियर है? Suppose there are two sources and they are sounding sound together, they are vibrating together in the same medium, maybe two tuning fork, okay, maybe two horns of a vehicle, of two vehicles, maybe a policeman, okay, and some other source. We will be able to hear the beats provided this condition is satisfied. We might hear a beat and we might be given a question where one of the source has a known frequency and other source has frequency unknown, and you have to calculate the unknown frequency. Okay, for example, suppose So can I take tuning fork as it is? Yeah, you have any doubt to understand? Have you seen tuning fork? Okay. Where is it available? Market में कहाँ मिलता है? Tuning fork? Market में नहीं मिलता. Market में. Okay. ये जो tuning fork होता है, इसके दो arms होते हैं. और इन दोनों arms के वाइब्रेशंस ऐसे होते हैं. या तो दोनों आर्म्स अंदर आएंगे या तो दोनों आर्म्स बाहर जाएंगे. ठीक है, लास्ट टाइम बताया था, बिकॉज ऑफ द सेंटर ऑफ मास. जरूरी नहीं कि दोनों आर्म को हिट करो आप. एक को हिट करोगे, दूसरा अपने आप हिट हो जाएगा, क्योंकि दे आर इंटर कनेक्टेड. बेवकूफों की तरह हिट करने के बाद कभी भी आर्म्स को मत पकड़ना, बिकॉज वंस यू होल्ड देम, द वाइब्रेशन विच यू हैव जनरेटेड दैट विल बी किल्ड. So how to hold the tuning fork? Normally, you hold the tuning fork by keeping your thumb right here at the junction and holding this rod in your hand. But please do not hold the rod alone, because while hitting it, it might slip from your hand. Witness a serious, dangerous case in physics lab once upon a time. Okay, when the child was hitting on a pad and just got slipped from the hand and it stuck to the eyebrow side of one of the child. And since it is made up of irons, it might cause some injury. So if you hold it the way I told you and then hit on a hard surface, either or a rubber pad, okay, then both the arms start vibrating. And when they vibrate, naturally they create sound. But the sound which they create, you can hear when you bring it close to the ear. Okay, again, don't touch the ear. Just place close to the ear, you hear the sound. It is something like something like this, you know. But the moment you move it away, the sound disappears. Sound disappears means sound is not there, या sound आप सुनाई क्यों नहीं देता? So tuning fork मैं यहाँ hit करूँगा, मुझे सुनाई देगा, आपको नहीं देगा. ऐसा क्यों? Why is that? आपको सुनाई नहीं दे रहा है तो साउंड है नहीं, या साउंड आप तक जा नहीं रहा है? क्यों नहीं जा रहा है? वेलोसिटी तो साउंड की वही होनी चाहिए मीडियम एयर में, 330 to 340 मीटर पर सेकेंड, और मुश्किल से 3 या 4 मीटर पे आप बैठे हो, साउंड को तो चला जाना चाहिए था. देन व्हाट इज हैपनिंग? व्हाट इज हैपनिंग देन? मैं तो जब बोल रहा हूं तो आपको सुनाई दे रहा है, लेकिन ट्यूनिंग फॉर्क कान के पास रखने पे सुनाई देता है, आप तक नहीं जाएगा. वो रेजोनेंस ट्यूब के मुंह पे रखने पे फिर पूरा साउंड आती है, जब आप एक्सपेरिमेंट करते हो वेलोसिटी ऑफ साउंड निकालने के लिए, लेकिन वैसे सुनाई नहीं देता. ऐसा क्यों? कान में फुसर फुसर करते हुए देखा है लोगों को? जब कुछ आप भी करते हो, बगल में कोई फ्रेंड बैठा है, उसके मुंह कान में ले जाके बोलते हो, आज सर जो पढ़ा रहे बहुत बकवास पढ़ा रहे, समझ में कुछ नहीं आ रहा. ठीक है, क्योंकि सर को तो सुनाई दे नहीं रहा है, सर तक आवाज नहीं गई, उसको सुनाई दे दी. Which is the issue here? Frequency or the intensity? Intensity is the issue. It is the intensity which is the issue. If the intensity is poor, long distance coverage is going to be very remote possibility. And that tuning fork which you hit on a hard surface, that tuning fork arms, they are capable of vibrating few number of molecules which are not that big intensity resources which carry the information for a long distance. कान के पास तो सुनाई दे देता है, लेकिन मैं जब बोल रहा हूं तो इसलिए आप सुन पा रहे हो क्योंकि आई हैव गॉट अ वोकल कॉर्ड व्हिच हैज गॉट अ थ्रोइंग कैपेसिटी ऑफ द एयर मॉलिक्यूल्स एंड दे possess the compressions and rarefaction for certain long distance. But I shouldn't celebrate कि मैं इतना तेज बोल सकता हूं कि ऑस्ट्रेलिया में क्रिकेट मैच चल रहा, किसी को मैं यहां से बोल के आउट करा दूं. ऐसे नहीं हो सकता, because still the voice is not that huge intensity कि इतना डिस्टेंस ट्रेवल कर ले. ठीक है, छोटी छोटी बातें, बट फिजिक्स एक्चुअली इंटरेस्टिंग ऐसे ही होती है जब आप अच्छी तरह से समझते हो, अदरवाइज तो रटने वाली बात हो जाती है. ठीक है, फाइन. सो इफ सपोज देयर आर टू सोर्सेज and the sources, one of the sources tuning fork of frequency say nu n, maybe it is 256 hertz. What is the meaning of this? These arms are vibrating in 1 second how many times? 256 times. There could be another tuning fork nu 2 which is not known, frequency is not known. Okay, now in problems which are asked related with the beats, there are so many disturbances which you create on one of the tuning fork, whether the known one or the unknown one, to change the frequency. We can have so many changes. Okay, this tuning fork might be having a frequency say nu2, but if I put some wax on this one or on this one, whosoever tuning fork has got a waxing done, wax, putting some wax means loading it with some heavy material. Why wax? Because wax is, as it is, very sticky. Okay, एक आटा जो चपाती बनाने वाला होता है वो भी आप उस पे चिपका सकते हो कुछ भी. But if it is heavy, then tell me, will the frequency now will reduce from the previous one, or it will increase from the previous one? Reduce. Now, one of the arm is to be put wax, but there is a limit of putting wax, because you should put a wax which sustain on the tuning fork while it is vibrating. इन्हें 1 किलो wax ले आके चेप दिया उस पे, जैसे हिट करोगे वैसे गिर जाएगा. अब टेक्निकलिटी इसमें आती है, क्योंकि मुझे कैसे पता कि कितना वैक्स रखोगे गिर जाएगा? मेरा काम ये थोड़ी, आपका भी काम ये नहीं है. तो फिर इतना ही वैक्स आप एंटरटेन करोगे कभी भी लॉजिकली, जितने वैक्स से जो डिफरेंस फ्रीक्वेंसी की जनरेट कर सकते हो वो कितनी कर सको? 10 हर्ट्ज. क्यों? क्योंकि वही एक पैरामीटर है ह्यूमन बीइंग के लिए, और तो कोई पैरामीटर फिट सेट कर नहीं सकता. दैट मींस वैक्स रख के फ्रीक्वेंसी कम करने की एक लिमिट है. 10 हर्ट्ज तक आप वैक्सिंग करके फ्रीक्वेंसी कम कर सकते हो, न्यूमेरिकल प्रॉब्लम सॉल्व करते समय कभी अगर अटक गए तो. ठीक है, अगर 10 हर्ट्ज से ज्यादा फ्रीक्वेंसी चेंज रिक्वायर्ड हो रही है तो उस प्रोसेस में वैक्स रखने के फिनोमेना को आप रिजेक्ट कर दोगे, दूसरा ऑप्शन चूज करोगे, क्योंकि उतना टेक्निकली मान लो कि पॉसिबल नहीं है. ठीक है, समझ आ गया? यू कैन ऑल्सो डू वन थिंग, यू कैन फाइल वन ऑफ द ट्यूनिंग फॉर्क ऑफ द वन ऑफ द आर्म ऑफ द ट्यूनिंग फॉर्क रेती से. ठीक है, पतला कर दो उसे, देन द फ्रीक्वेंसी विल increase. How much you can file? Till the change which you bring about, how much? 10 hertz, not more than that. Okay, is it okay? Fine. Suppose, let's do one problem. Okay, suppose they two are vibrated together and the beat frequency is heard around 6 hertz. Fine. Let us begin with a simple problem. आप आंसर बताते जाओ मुझे फटाफट. I have taken two tuning fork. One is 256 hertz, second one is unknown. And when I vibrated them together, I have heard a beat of frequency 6 hertz. Tell me what is the possible options of the frequency of the second tuning fork. Come on. What are the possible options of the frequency of the second tuning fork? Number 1, 250 hertz. Number 2, or 262 hertz. Agree? Okay, because these two frequencies, when you take the difference from 256, either you take this minus this or this minus this, the result remains 6 hertz. Okay, इस तरह से क्वेश्चन आएगा नहीं, अदरवाइज तो नर्सरी वाले कर लेंगे, प्रेप वाले. ठीक है, तो ये तो लेकिन समझ में आ गया कि 2 ऑप्शंस हैं. आउट ऑफ 2 ऑप्शंस कभी कभी कोई एक ऑप्शन चूज करने के लिए कुछ और डेटा प्रोवाइड कर देते हैं. फॉर एग्जांपल, ये डेटा समझ में आ गया ना? आपके पास बहुत सारे ऑप्शंस हैं, एटलीस्ट 4 परमुटेशन कॉम्बिनेशन तो मैं ही बना सकता हूं. जैसे वैक्स रखना है, वैक्स रखना है मान लो, तो वैक्स कहां रखा जा सकता है? इस पे भी 2 ऑप्शन. ठीक है, फाइल करना है, इस पे भी, इस पे 4 ऑप्शन. ठीक है, वैक्स भी रखूं, फाइल भी करूं, उसके भी परमुटेशन कॉम्बिनेशन बनाओगे मैथ्स के हिसाब से, तो उसके भी 2 3 वैक्स 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 फाइल फाइल. ठीक है, वैक्स फाइल फाइल वैक्स, आई मीन जैसे करते नहीं मैथ्स में, इस तरह के बहुत सारे ऑप्शंस बन जाते हैं. दैट मींस रटने वाले बुरे फंसते हैं इसमें, रट नहीं सकते, सोचना ही पड़ेगा गिवन सिचुएशन में कि एक्चुअली हुआ क्या जिसकी वजह से हमें वो अननोन फ्रीक्वेंसी निकालनी है. लेट्स डू वन ऑप्शन देता हूं. ठीक है, now it is given that when the second tuning fork, this one unknown tuning fork, has been filed, okay, when the second tuning fork has been filed little bit, then the beat frequency, new beat frequency has increased to say 8 hertz, and as becomes 8 hertz. But this happens after filing. कौन सी filing की? Second tuning fork. After filing the second tuning fork, The new beat frequency has become 8 hertz. Now, out of the two options, only one option is correct. Which option is correct? Come on, children. Let's see. Okay. मुझे आता तो कुछ नहीं, लेकिन लॉजिक आता है, बस लॉजिक से ही देखते हैं. आ जाओ आप भी. चलो मान लिया कि जो भूल गया, आई फॉरगॉट हर नेम, ऊर्जा ने जो कहा, से दैट इज 262 hertz. N2 is 262 hertz. After filing it, had it been 262, जब आप फाइल करोगे तो will it become more than 262 or less than 262? Obviously फाइल करने से फ्रीक्वेंसी बढ़ती है. ठीक है, तो 262 को आप मोर करके, फाइल करके, बढ़ा के आप इसको कितना कर सकते हो? 264 कर सकते हो. ठीक है, 264 होने के बाद नया बीट फ्रीक्वेंसी कैसे निकलेगा? 264 माइनस 256 कितना आ गया? और यही है गिवन ऑप्शन, यही तो दिया था. This is the given option. Therefore, this is the correct answer. Let's see that had it been a child choosing the other one, गलती कहां होती? ये तो चलो आ गया. अगर किसी ने 250 लिया होता, ओके, देखें 250 अगर होता, आप इसको फाइल करो. If N2 is equal to 250, फाइल करो इसे 252 को, फाइल करके बढ़ाओ 256 और बढ़ाओ 252, 254 और फाइल करो ना, करो फाइल 256, 258, क्योंकि फाइल करने की भी कोई लिमिट होनी चाहिए. वही मैं बताया था आपको शुरू से, क्योंकि कहीं कहीं ऐसा ऑप्शन जरूर आएगा, एटलीस्ट जेई लेवल पर जरूर आएगा, जहां पर दोनों ऑप्शंस सही होने लगते हैं, और फिर हमें यह सोचकर एक ऑप्शन को हटाना पड़ता है कि वो 10 हर्ट्ज वाली क्राइटेरिया हम क्रॉस नहीं कर सकते या डिसओबे नहीं कर सकते. इधर देखते हैं कितनी हर्ट्ज की फ्रीक्वेंसी में चेंज करूं, 250 को फाइल करते करते कितना मैं बढ़ाऊं कि मुझे बढ़े हुए का डिफरेंस 250 को मैं बढ़ाकर कितना कर दूं? 264 हो सकता है. 250 को बढ़ाते जाओ, 264 तक ले जाओ, फाइल करके कितने का डिफरेंस लाया आपने? 14 हर्ट्ज से बहुत बड़ा हो गया, एटलीस्ट 10 हर्ट्ज से तो बड़ा हो ही गया. तो ऑप्शन वैसे लॉजिकली अगर ये किसी को नहीं पता होता कि ह्यूमन बीइंग की जो प्रॉब्लम है 10 हर्ट्ज के बियॉन्ड बीट सुनने की नहीं है, तो ये ऑप्शन भी सही होता. चमगादड़ों के लिए एक फिजिक्स का न्यूमेरिकल करो तो ये भी ऑप्शन सही है. ठीक है, क्योंकि फाइल करके ही बढ़ाना है तो ये भी ऑप्शन सही है. और फाइल करूंगा, सुबह से लेकर दोपहर तक फाइल ही करता रहूंगा, बट वी विल रिजेक्ट दिस ऑप्शन. ठीक है, वो वाला थोड़ा आराम से आ जा रहा है. फाइन, समझ आ गया? ओके, लेट्स डू वन मोर प्रॉब्लम. व्हाई डोंट यू गिव अस अ प्रॉब्लम? इनको आईटी जेई का ही प्रॉब्लम कराते हैं. आईटी जेई, यस, नहीं नीचे आईटी जेई. हाँ यही था. इसमें हम लोगों ने उस दिन कुछ क्वेश्चंस किए थे, बट वेट, ओके, नेक्स्ट. Let them try. Yeah. Not this. खोलिए. ओपन दैट IIT JEE. इन द मीन टाइम, जब तक आप ओपन करें तब तक मैं इनसे इसी क्वेश्चन को ट्विस्ट करते हैं. इसी में सपोज करो ये ऑप्शन नहीं दिया होता कि ऑन फाइलिंग द बीट फ्रीक्वेंसी हैज गॉट 8 हर्ट्ज, कुछ और ऑप्शन देते हैं. ओके, ऑन पुटिंग वैक्स on the known tuning fork. I'm changing the option. Okay, on putting wax on the known tuning fork, the beat frequency has reduced to 2 hertz. ठीक है, find the unknown frequency. अब करो, नोट कर लो कहीं पर. When two tuning forks are vibrated together, question नोट कर लो. When two tuning forks are vibrated together, space, beat frequency generated is 6 hertz. On putting wax on the first tuning fork of frequency 256 hertz, on putting wax on the first tuning fork of frequency 256 hertz, the beat frequency reduces to 2 hertz. Find the frequency of the second tuning fork. Next, IIT JEE 1, similarly IIT JEE 2 कहाँ है? जैसे 1 है, नीचे आ जाइए. नहीं है, हाँ उसी दिन का तो इतना ही है. अच्छा, ये तो हमारे पास मेल है. आप मेरा मेल खोलिए, मैं दे देता हूँ आपको अपना मेल, पासवर्ड वगैरह डाल देता हूँ. ओपन माय मेल. आ गया जी. मैं स्लो क्यों है? सिक्स टू 9706 सारा डाउनलोड कर लो
All.
हाँ जी बताइए कौन सा आंसर सही होगा इस बार 250 okay let me check n2 will be let 250 hertz in the beginning n2 minus n1 was 6 hertz it is given now after waxing किस पे वैक्स कर रहे हो द नोन वन अननोन वन known one that means n1 dash 256 hertz से घट जाएगा it will be 252 hertz घटाना ये तो उतना घटाते हैं जितने काम चल जाए मेरा ठीक है and therefore the new n2 minus n1 dash will be 2 hertz which is given option दूसरा वाला ऑप्शन अगर होता 262 तो कितना वैक्स रखते उस पे कि वो एटलीस्ट 10 हर्ट्ज का डिफरेंस ठीक है ये भी सही है क्योंकि 10 से ज्यादा के लिए मैंने मना किया था 10 तो एक्सेप्ट कर सकते हो लेकिन अब कंपेयर करके बताओ कौन ज्यादा डिफिकल्ट है ठीक है ऑब्वियसली 10 हर्ट्ज का चेंज ले आना वैक्स लगा लगा के तो पागल हो जाओगे इतना वैक्स नहीं ले आते ठीक है समथिंग लाइक दैट यू समटाइम्स यू हैव टू गो फॉर दीस काइंड ऑफ neglecting one option on this logical basis and choosing the other one fine is it okay open sir second one yes just increase wait ऊपर just a minute next page I mean next page मतलब इस तरफ का ऊपर next एक मिनट next हाँ ऊपर हाँ चलो कोई नहीं इसमें कोई पिछले साल के आईआईटी के पेपर्स में एक भी क्वेश्चन नहीं एक बार हमने एक और नोट्स होगा आप इसको बंद करिए एक हमने इनको लास्ट टाइम आई गिव यू 56 क्वेश्चन सेट ऑफ 56 क्वेश्चन इफ यू रिमेंबर टाइम मिला था देखने का नहीं 3 बच्चे तो थे सिर्फ आप भी थी there was another set of questions MCQ 56 have they uploaded that आपने अपलोड नहीं किया था अच्छा आप उसे खोलिए उसमें there will be another set of questions हाँ पीछे जाइए वेव्स में जो आपने भी डाउनलोड किया ना उसमें एक तो मेरे ये नोट्स हैं ये ठीक है एक ये IIT-JEE का क्वेश्चन है एक ये वेव 1 वेव 2 करके है इसको खोलिएगा इसमें करीब पांच पेजेस होंगे हाँ ये सारे 1 2 3 4 इसमें बहुत अच्छे अच्छे क्वेश्चन हैं हाँ इंक्रीज करिए जरा ठीक है नेक्स्ट पेज यस नेक्स्ट पेज Next. Next. Question number 48 खुलेगा. I mean, just पढ़ा के 48. Just see children, 48. Try them. Try it. A vibrating string produces 2 beats per second when sounded with a tuning fork of frequency 256 hertz. There is a vibrating string. Last time you're not there. Any string can be given a tension and pluck from middle, and that string starts vibrating. What do you see? Nodes and antinodes. Nodes is the place where displacement is minimum or zero, and antinodes where displacement is maximum. Depending upon the number of nodes and antinodes, the frequency of the string is determined. The fundamental frequency corresponds to 2 nodes at the end and 1 antinode in the middle, and so on and so forth. ठीक है, ये basic funda है. Fine. Okay. Now see this question 48. Should I write the formula of the frequency in a string? You remember that? Frequency, जो लोग थे present वो बताएं, what was the formula of vibration? If the string is vibrating in nth harmonic. You were there, I can recognize you. Okay, बच के नहीं जा सकते बच्चे आज. You also were there, and that girl also there. बताओ जी क्या था formula? N upon nth harmonic, N upon 2L, where mu is the mass per unit length and L is the length between the two fixed points. ठीक है? Where N is this N is the number of harmonic, T is the tension. चलो चलो शुरू हो जाओ फिर. मैंने थर्ड हार्मोनिक का डायग्राम बनाया. This is the correct answer. Two options are there only. Either it will be 254 hertz or 258, and incidentally दोनों options आपके पास available है चारों option में से. बट दोनों में से कोई एक ही ऑप्शन चूज करोगे ना. चलो. When you increase the tension, what happens to the frequency of this? It increases. So, is it increasing? Yes. Earlier it was 2. Now it is 3. So it's very simple that it should be 258 hertz. In the beginning, 258 minus 256 कितना आया? 2 hertz given था ये. After the tension has been increased, it will be now 259. Am I right when I say 259? Because by increasing the tension, you only told that frequency will increase. Minus 256, which is 3 hertz. ठीक है? Logically आप दूसरा ऑप्शन भी चूज कर सकते हो यहाँ पर, बट तकलीफ उसमें ज्यादा होगी. तकलीफ वाली बात समझ में आ रही ना? अगर किसी ने 254 हर्ट्ज चूज किया, ओके, 254 हर्ट्ज में चेंज ले आते उसको बेचारे को कितना चेंज ले आना होगा? 259 तक जाना होगा. दैट मींस 5 हर्ट्ज का चेंज ले आ रहा, जबकि लैंग्वेज है क्वेश्चन का स्लाइटली इंक्रीज किया टेंशन. तो स्लाइटली में स्लाइटेस्ट ऑप्शन जो होगा उसी को लेकर आप आंसर मार्क करके आओगे. ठीक है? फाइन. ओके. So I leave it now. We will club this beat with the resonance tube, tuning fork, and string, anywhere, wherever we, sometimes when Doppler effect also, get clubbed with the beats. But before I start clubbing them, let's do the Doppler effect also. We finish the content, then we start doing the problem. Doppler effect. We will do Doppler effect in sound. First, if there is a source and there is an observer and they both are at rest, then what it emits is what it hears. In terms of intensity नहीं, in terms of frequency. ठीक है, मेरी आवाज आप तक जो पहुंच रही है उन तक कम पहुंच रही होगी, लेकिन फ्रीक्वेंसी बिलीव मी मेरी वही है, इंटेंसिटी कम हो रही वहां आ गया. ठीक है, तो फ्रीक्वेंसी के टर्म्स में वी आर पर्टिकुलर है, इंटेंसिटी के टर्म्स में नॉट पर्टिकुलर है. इंटेंसिटी घट सकती, बढ़ सकती, कोई टेंशन नहीं है. अगर मैं इन दोनों को चला दूं, मूव करा दूं, ठीक है, तो इट इज ऑब्जर्व दैट what it emits is not the same as what it observes या what it receives. But एक केस ऐसा है जिस केस को अवॉइड करना होगा, और वो टेक्निकली काइनेमेटिक्स के टर्म में वो चलते हुए भी नहीं चल रहे हैं. And what is that case? When they both are moving in the same direction with the same velocity. सिर्फ वो केस अगर अवॉइड कर लो, बाकी जितने भी केस तुम सोच सकते हो वो सोच लो. हर केस में देयर इज अ रिलेटिव मोशन बिटवीन द सोर्स एंड ऑब्जर्वर, ईदर टुवर्ड्स ईच अदर और अवे फ्रॉम ईच अदर. Then in all the cases, what it observes if it is apparent frequency nu A, what it emits if it is nu naught, then nu A happens to be nu naught V minus V O upon V minus Vs. It's a general formula. General formula. And this formula is valid when both source and observer, they are moving in positive direction. And what is positive direction? Positive direction कौन बताएगा? What is positive direction? Direction of sound. And direction of sound is always from source to observer. This is how it goes. Okay, so learn only one thing. This formula is valid only when both are moving in positive direction, and it's a common sense that positive direction happens to be the direction of sound. Another common sense that sound travels from source to observer. Okay, so positive direction, source to observer. Okay, fine. Derivation नहीं चाहिए. Let's now have most general formula. This is general formula. We can have a most general formula, and in most general formula we can accommodate the medium movement as well. It could be the motion of the medium also affecting the whole case. Could be the air is moving. Could be there is a inside water, some phenomena is occurring. Some sound source is emitting sound. And since water itself is flowing in particular direction, the flow of water is also going to be affecting the apparent frequency. So if I accommodated that, if I consider the medium movement as well, then the most general formula becomes this way. Nu apparent is nu original V minus VO plus minus V medium upon V minus Vs plus minus V medium. Plus minus. When to take plus and when to take minus. Before you answer that, these minus signs are representing, indicating when both the observer and sources are moving in which direction? Positive direction. That is from source to observer. Not forgetting that, keeping in this thing in mind. Now you tell me कि यहाँ प्लस माइनस क्या होना चाहिए? प्लस साइन कब यूज करूं, माइनस कब? प्लस व्हेन मीडियम इज मूविंग, positive direction. Okay, so don't forget that you are here saying plus for the positive and here you said negative for the positive. मैं ये बताना चाह रहा था, ठीक है, ढंग से समझ लो, इसे गड़बड़ी मत करना, ठीक है। यहां जब मैंने आपसे पूछा था, आपने नेगेटिव साइन के लिए क्या एडवोकेट किया आपने, कि व्हेन द सोर्सेज आर मूविंग इन पॉजिटिव डायरेक्शन, और यहां आपने चुपके से बोल दिया पॉजिटिव साइन इंडिकेट्स व्हेन द मीडियम इज मूविंग इन द पॉजिटिव डायरेक्शन। याद रखना, दैट मींस दिस प्लस माइनस plus Vm plus indicates when medium is moving in positive direction. That is source to observer. ठीक है? Is it okay? Fine. There are various possible cases. We can discuss one by one all these cases before we start doing problems. I will tell you the case. You please tell me the correction in the formula. फटाफट बताइए. Let's take this case one. VO is 0, VS is negative. पहले डायग्राम बनाइए फिर फॉर्मूला लिखिएगा। चलो पहले फॉर्मूला लिख, फॉर्मूला आसान है। पहले फॉर्मूला बताओ क्या होगा। न्यू ए इज न्यू ओ वी अपॉन वी प्लस वी एस। मीडियम को चलो छोड़ देते हैं फिलहाल, जब जरूरत पड़ेगी तो देख लेंगे। व्हाट अबाउट द डायग्राम? किसको किधर मूव करूं? Source is moving away from the observer towards my right. Observer is not moving. ठीक है? Is it okay? Fine. Second case, I'm giving you the diagram. You please tell me the formula. Tell me the formula. इतना लिख दिया, टफ पार्ट था उसको लिख दिया, बाकी आप बताओ। V प्लस VO अपॉन, क्या बात है, वेरी गुड। थर्ड केस, इसका बताओ। V माइनस VO अपॉन V प्लस VS। ये तो आपको सारा आता है। इसका बताओ। इसका बताओ। Is it agreed? कुछ गड़बड़ तो नहीं है? खामोश बैठो सारे हैं। ऐसे तो मैं कुछ भी आम घास लिख दूंगा बोर्ड पे, सब सही होगा फिर। ठीक है ना? ओके, ये केस Case 5. अब क्या करेंगे? Source is not going towards observer. It's going like this, the way I have shown. Observer is at rest. We start now resolving. We can now take that component of the velocity of the source which is relevant for us. And what is that relevance I'm talking about? The component which makes the source approaching towards the observer or moving away from the observer. Easily tell me, what is that component? Vs. So in place of Vs, you please handle the situation by putting Vs cos theta. Tell me the formula now then. V प्लस या माइनस? अच्छा अच्छा अब तो कोई ऑप्शन ही नहीं, कोई एक ही प्लस या माइनस? माइनस. पहले प्लस बोला था, एक बार अच्छा बोलने से बदल दिया. ओके फाइन. It's not the big error which we commit, plus and minus, but I wonder that this is the biggest error at the end of the day happens by any IIT and RJE in the numerical problem, because this is the error which can easily be avoided. So be careful when plus and minus error is there. Optics will be similar topic where you do commit a mistake of plus and minus during the sign convention. Fine. Got it? Ready to do some problem now? Let's start doing some problem. We have got many problems now based on Doppler. Achha, one formula I told last time, I don't remember the formula. I can show you what happens when the source and observer, out of the source and observer, source starts moving with some acceleration. The velocity is not constant. Then probably the formula which I have been discussing here up till now, that formula fails. Because this formula is valid only when the case is of uniform motion. वो लिख लो आप, दोबारा लिख लो. If source is moving in the positive direction with some acceleration a. Sir, मेरे notes दिखाना मुझे. ऐसे तो मुझे अंधकार छाया हुआ है, फिर भी आप ये दिखा दो. Okay, next page. Next page. हाँ, yes, थोड़ा बड़ा करना है इसे. हाँ, इसमें तो एक्सेलरेशन वाला है नहीं. नेक्स्ट पेज. एक पेज और था, लास्ट पेज. हाँ ये था. हाँ ये था. ये फॉर्मूला है बच्चों, नोट कर लो. जस्ट मैग्निफाइड. दिस वन, न्यू ए इज इक्वल टू 2v nu square upon 2v nu minus a, where nu is the original frequency, v is the velocity of sound, and a is the acceleration. Let's check the common sense. Common sense is very important in applying the Doppler effect cases formula. If source is running towards the observer, frequency will be more or less as heard by the observer. If the source start running towards the observer, frequency will increase, or apparent frequency will increase or decrease? Okay. And apparent wavelength? Decrease, because they are reciprocal to each other. Okay? Is it okay? if I am running towards a wall and the wall has been fixed a mic, just like mic here in my collar somewhere here. And if I'm running towards a wall, wall since has a mic, wall will act as an observer. But दुनिया के सारे wall normally rest पे होते हैं, तो I can assume that that wall is also at rest. So observer, which is a wall here, non-living observer having a mic, will be treated as if it is at rest and the source is moving towards the observer. And in many cases, children, the sound also possesses the phenomenon of reflection, just like the light. Echo is the result of the reflection. Don't forget. Okay. So when I run towards a wall, maybe I am going to hear the sound which the wall reflects back, as well as my original sound. I'm sure that when you speak, you hear yourself. You do, yes, even I do. So when I speak, when you speak, when he speaks, we hear ourselves. But by God's grace, somehow we are not able to identify our voice. Okay, बस इतना लगता है कि हम कुछ बोल रहे हैं, जिंदा हैं, कुछ बोल रहे हैं बस. लेकिन हमारी आवाज की क्वालिटी क्या है? टिम्बर जो होती है, टिम्बर रिकॉग्नाइज करना पॉसिबल नहीं होता. वो तो टेप रिकॉर्डर में टेप करके सुनते हो तो अच्छा ये मैं बोल रहा था, ऐसे मेरी आवाज ऐसी इतनी घटिया सी है या इतनी अच्छी सी है, समथिंग लाइक दैट. So when you hear yourself, the frequency naturally is going to be the one which you speak. But when you hear a frequency reflected by the wall, then the frequency which you hear is going to be the frequency which the wall reflects back. And that frequency is not going to be the same as you have emitted out as a source. As a situations we can face during the numerical problem. Okay, so there could be a beat frequency. In fact, in some very interesting cases, it could be a court case on the police wala who charges, money to a driver who rushes towards a red light and ignores the whistle of the police wala. Because I might ignore his whistle, because I might claim that as per the Doppler effect, the frequency, the beat frequency which I heard, sir, Judge, Sahab, that has gone beyond my audible capability of bifurcating 10 hertz. And it could be very much possible. Okay, because I'm running and naturally he is whistling. He wanted to stop me because there was a red light, but I didn't hear, because the frequency which I heard, that was actually giving me some beat as compared to my original frequency, which as it is I will be able to hear because I'm putting the horn there. So these cases could be there. Let us see one by one interesting Doppler effect cases. But before I move on, let me tell you the formula of Doppler's effect in light. Not in CBSE, but you can always attempt questions of competitive level. After it's in light, delta nu is plus minus V by C nu. Delta lambda is plus minus V by C lambda. And these are called Doppler shift. Doppler's shift. Delta nu and delta lambda, they are called Doppler shift. Okay. Remember the meaning of plus and minus here. Delta lambda is actually the lambda apparent minus lambda original. If it is positive, then this shift is known as red shift. Have you heard? If it is positive, then this shift is known as red shift. And that indicates that the source of light is moving away from observer. Obviously, then only the wavelength will be increased and the frequency will be decreased. This is very much the case of all the stars and the planetary objects. I mean the terrestrial objects, they are moving, celestial objects, they are moving away from us, which was originally considered as the big proof, scientific proof of Big Bang theory, where it was proposed that once upon a time there was a big blast, and out of the big blast all these stars and the galaxies, different parts of the world that has been created, and they are since then they are moving away. Right now we don't accept that theory. Big Bang theory is no more considered to be the true theory of the evolution of world. Okay, fine. This is also the case when the doctors they go for the color Doppler effect to test the heart condition of a patient, where they pass a particular waves and they get the reflected waves out of the heartbeats, and then they analyze that particular frequency, and that shift related observation is known as the color Doppler test or the color Doppler effect. Fine, is it okay? C is the velocity of light in air or vacuum, and V is the velocity of, no, not sound. So velocity of, C is the velocity of light and V is the velocity of either the source of light or the observer. But let's be practical here. Let's be practical. You will find that this is very interesting effect, and this interesting effect, Doppler effect in light, has to be bifurcated from the Doppler effect in sound. There is a term called symmetry in Doppler effect, and that symmetry exists in light but it doesn't exist in sound. Have you heard about this? 11th class में पढ़ा था ये? नहीं? सुनो अब ध्यान से. ये मैटर करता है कि सोर्स चल रहा है या ऑब्जर्वर चल रहा है या नहीं करता, ये पहले इस पे डिस्कस करते हैं. डज इट मैटर विच इज मूविंग, सोर्स इज मूविंग और द ऑब्जर्वर इज मूविंग? साउंड के केस में डिस्कस कर रहा हूं, ठीक है? साउंड के केस में सोर्स चल रहा है, ऑब्जर्वर रेस्ट पे है, या ऑब्जर्वर चल रहा है, सोर्स रेस्ट पे है. क्या ये दोनों केसेस सेम है या अलग अलग है? अलग अलग है. पूरी तरह से एक्सेप्ट कर लें विश्वास के साथ, फिर आगे बढ़ते हैं. अलग अलग क्यों है? बताओ बेटा, अलग अलग क्यों है? Why they are separate? Even if the velocity is same, तब भी अलग अलग है. मतलब ऑब्जर्वर रेस्ट पे है, सोर्स चल रहा है, मान लो Vs, ये सोर्स Vs 10 मीटर पर सेकेंड से चल रहा है. बताओ डॉपलर इफेक्ट से क्या निकलेगा? फ्रीक्वेंसी V अपॉन V माइनस 10. ठीक है, जो भी आया. ऑब्जर्वर को चलाता हूं, सोर्स को रेस्ट पे रखता हूं, रेस्ट Vs 0. ऑब्जर्वर को चला दो, 10 मीटर पर सेकंड से चलाना. काइनेमेटिक्स की लैंग्वेज में सेम है दोनों केस. काइनेमेटिक्स की लैंग्वेज में जितनी रिलेटिव वेलोसिटी इस समय इसकी थी, वही रिलेटिव वेलोसिटी इस समय इसकी आएगी. लेकिन देखना केस अलग अलग हो गया. नाउ न्यू एपरेंट विल बी न्यू ओरिजिनल V माइनस या प्लस? अच्छा प्लस नहीं, सोच के बताओ. देखो गड़बड़ कर रहे हो. माइनस प्लस किस तरफ चल रहा है? ये पॉजिटिव या नेगेटिव? तो फिर प्लस हो गया ना. मैं जब आपकी तरह था, गलती करता था तो कॉमन सेंस से सही करता था. इस समय इसके बढ़ने पर, आगे बढ़ने पर आपको लगता है कि फ्रीक्वेंसी जो होगी वो बढ़कर सुनाई देगी या घटकर सुनाई देगी? तो न्यूमरेटर में घटाने का जरूरत कैसे कर सकते हो आप? वो न्यूमरेटर में तो मैथ्स आती, सबको आती है. कोई चीज घटेगी न्यूमरेटर में तो ऑब्वियसली रेशियो कम हो जाएगा. एनीवे, नाउ in spite of same quantity being subtracted here and being added here, this ratio, maths people say the ratio doesn't remain same. 5 upon 5 is what? बहुत टफ क्वेश्चन, जल्दी बताओ. 5 plus 10 upon 5, बोलो. 5 upon 5 minus 10, अगर मॉड ले लूं, ठीक है? जबकि मैंने सेम चीज न्यूमरेटर में ऐड किया और सेम सबट्रैक्ट किया. कहने को हम कहते हैं कि न्यूमरेटर में कोई चीज बढ़ती है तो रेशियो बढ़ता है, डिनोमिनेटर में कोई चीज घटती है तो रेशियो बढ़ता है. दोनों केस में रेशियो बढ़ता है, लेकिन अमाउंट अलग अलग होता है. दैट्स वेरी सिंपल मैथमेटिक्स. आई थिंक जब बचपन में आपको पढ़ाया गया होगा, बताया होगा कि सेम नंबर के साथ अगर आप ऐड या करो या सबट्रैक्ट करो न्यूमरेटर डिनोमिनेटर में, तो रिजल्ट सेम कभी नहीं आता. इसका मतलब डॉपलर इफेक्ट में ये मैटर करता है कि सोर्स चल रहा है या ऑब्जर्वर चल रहा है, भले सेम वेलोसिटी से चले तो. And such a Doppler effect is called asymmetrical Doppler. Why asymmetrical? Because it does make a difference which one is moving. So asymmetrical Doppler effect. लाइट के केस में मैटर नहीं करता. लाइट के केस में सोर्स चले चाहे ऑब्जर्वर चले, मैटर नहीं करता. उसके पीछे एक कारण है. लाइट के केस में डॉपलर इफेक्ट सड़कों पे नहीं देखी जाती, जहां पर सड़कों पे हेडलाइट जला के कोई ड्राइव कर रहा है, क्योंकि दुनिया का कोई भी व्हीकल सड़क पे जब चलेगा तो उसकी जो वेलोसिटी होगी स्पीड ऑफ लाइट से कोई कंपैरिजन नहीं हो सकता। ठीक है, ज्यादा से ज्यादा कितनी स्पीड से चला लेगा कोई गाड़ी? लाइट सोर्स हम आसपास आजू बाजू जो देखते हैं, ज्यादा से ज्यादा मैक्सिमम कितनी स्पीड हो सकती है? 60, 70, 80। मारना क्या लोगों को वहां पर चला के इतना तेज? ठीक है, 60, 70, 80, 120, इससे ज्यादा आप वैसे नहीं चला सकते, खुद भी तो मरोगे। स्पीड ऑफ लाइट कितनी है? 3 × 10⁸मीटर पर सेकेंड। सवाल ही नहीं पैदा होता उतनी स्पीड के बारे में कोई व्हीकल सड़क पे चलने की सोच सके हम। इसका मतलब लाइट के अंदर डॉपलर इफेक्ट जब हम करते हैं तो जो वेलोसिटी होती है ऑब्जर्वर या सोर्स की, उसको जमीन पर, ग्राउंड पर फीजिबली पैदा करना इज ऑलमोस्ट इम्पॉसिबल। सिर्फ स्टार्स या सेलेस्टियल ऑब्जेक्ट्स ही हैं जो इतने फास्ट चल सकते हैं, जमीन पे तो हो नहीं सकता कंपेयर टू द वेलोसिटी ऑफ लाइट। ठीक है, और एक चीज, ये मैटर नहीं करता कि सोर्स चल रहा है, उस रेंज में ये मैटर नहीं करता कि सोर्स चल रहा है ऑब्जर्वर चल रहा है, उस रेंज में मैटर नहीं करता। मैंने बहुत पहले एक क्वेश्चन देखा था कि टू फोटॉन्स आर मूविंग इन द सेम डायरेक्शन, व्हाट इज द रिलेटिव वेलोसिटी ऑफ वन फोटॉन विद रिस्पेक्ट टू ईच अदर? इफ द वेलोसिटी ऑफ फोटॉन इज c, द अदर वन इज आल्सो मूविंग विद c, नॉर्मली काइनेमेटिक्स के एंगल से बच्चे क्या करेंगे? इसका आंसर क्या देंगे? 2c, विच इज द रॉन्ग आंसर, बिकॉज स्पीड ऑफ लाइट तो आज तक ब्रेक नहीं हो पाई, आपने तुरंत 1 सेकंड में ब्रेक कर दिया। 2c, क्या बात है? ठीक है, बिकॉज द रिलेटिव वेलोसिटी कंसेप्ट ऑफ काइनेमेटिक्स कैन नॉट बी एप्लीकेबल फॉर द quantum mechanics and the case of light. Okay, fine. So Doppler effect in light happens to be therefore symmetrical Doppler. It doesn't matter which one is moving, source is moving or observer. So in this formula जो मैं रब्त कर चुका हूं, what is V therefore? Velocity of source कह लो या observer कह लो। ठीक है, velocity of source होगा तब भी V रखेंगे, observer होगा तब भी V रखेंगे। Fine, is it okay? Now let's move. Sir, show me the problem. No, this I have last time I have already covered. Let's go to this seat, second seat. You start doing children now. We'll discuss the problems, but I will be requesting you to first attempt, and then probably in case if you have doubt, then I will help you out, and then we move on. हमने 13 तक कर लिया था, 14 से स्टार्ट करो। लास्ट टाइम 13 तक कर चुके हैं। ठीक है, प्लीज गिव देम दीज क्वेश्चंस सो दैट दे कैन गो थ्रू वंस अगेन। क्वेश्चन नंबर 14 से स्टार्ट करो। फॉर्मूला फ्रीक्वेंसी इज 1/2L, फंडामेंटल मॉड की फॉर्मूला T/म्यू। व्हाट इज म्यू? जो आप कह रहे हो वही मैं लिख रहा हूं, मास पर यूनिट लेंथ, लेंथ ऑफ द स्ट्रिंग। इसमें फर्क है। व्हाट इज दिस स्मॉल एल? व्हाट इज स्मॉल एल? Small l is always the length of the string between two wedges or two fixed point where automatically two notes are generated. And what is capital L? Capital L happens to be the length which you consider in order to find mu. कोई भी लेंथ ले सकते हो, जितना लेंथ लोगे उतना मास ले लो, उसका मास अपॉन उसका लेंथ। ठीक है, अब ऑब्वियसली मैं मास को लिख सकता हूं डेंसिटी इनटू वॉल्यूम। ठीक है, ए को लिख सकता हूं मैं πr², अज्यूमिंग द वायर टू बी सिलिंड्रिकल। तो नया फॉर्मूला क्या बन गया? बोलो, रो πr², where rho is the density of the material of the wire, pi is pi, and r is the radius. Now you attempt the problem and tell me the option. Which option is the correct option? Speak the answer. ठीक है, कभी कभी उनकी तरफ एक कैमरा होना चाहिए, पता तो लगे कि बच्चे बैठे जिनको पढ़ा रहा हूँ. यस बेटा, आंसर. Sir will tell me which is the correct answer. Then only I will. And if that is the correct answer which you told, then you have to come on the board and solve it. So that is the punishment of telling the correct answer. So next time she will not tell the correct answer. That is the punishment. आंसर होगा लास्ट में, एक आंसर सीट होगी, उसको अलग से करके खोल के रख लीजिए आप. ये, हाँ ये वाला, यस यस, ये क्वेश्चन नंबर चेक कर लीजिए और आंसर बता दीजिए. इसको आप अपने पास रखिए, हाइड कर लीजिए. कहाँ है, कहाँ हाइड किया, मुझे तो दिखाओ, मुझे भी नहीं दिखाओगे. अच्छा, मेरे साथ चीटिंग करते हो, मुझे दिखाओ. अच्छा सेम, तो नहीं, ऐसा नहीं हो सकता यहाँ दिखे वहां ना दिखे. लगाइए अपना टेक्निकल माइंड. और बाकी लोगों के कितने आंसर आ रहे हैं? सभी के 2, 1. ये तो मैं चाहता हूं सारे 4 लोगों के 4 आंसर आने चाहिए. None of these. Okay, new one क्या निकाला? new 1 is to new 2 ना? So new 1 is to new 2. आ जाओ. 1/2. पहले का लेंथ क्या है? L. 1/2L रूट, सेम टेंशन है, T अपॉन रो. पहले का रेडियस, आई मीन, अच्छा 4r². ओके, नहीं बाहर नहीं लेंगे, आई मीन लेना चाहे ले सकते हैं, कोई बात नहीं. अपॉन, ठीक है, अपॉन 1/4L रूट T अपॉन रो. सेम लू, क्यों? मटेरियल सेम है, दिया हुआ है, डरने की बात नहीं है. ठीक है, डर के आगे जीत है. ओके, रो पाई r². मैंने बताया था कभी आपको, मुझे इसमें बहुत मजा आता है. सब कट जाए तो और अच्छी बात. बचा क्या? इधर 4 बाहर गया तो 1/4, 1/4. अरे ये तो 1 आ गया. ठीक है, आई थिंक शी वाज राइट. नेक्स्ट क्वेश्चन. नेक्स्ट सर. Which question is this? Let them try. How to write energy of a wave, that too in a string? Some proportionality relation. Is it proportional to square of the amplitude or square of the frequency? Square of the frequency. Larger the frequency, larger will be the energy. Don't you feel that larger frequency means more number of loops would be generated? If I have a string which is produced one loop only at the middle, and another, as compared to that, I have another string which has got 6 loops. So don't you feel for 6 loops you have to generate more energy to vibrate, to have to pluck hard? Okay, so energy is proportional to square of the frequency. If you go by this, then probably you find the answer, because two of the term here, one term is representing the frequency, other is representing the wave number. So just ignore the wave number wala term and just see the frequency wala term. So what is the frequency ratio? 1:2. So energy will be also square of that. So which is the correct option? C is the correct option. Okay, somewhere we can note down that energy is proportional to square of the frequency. Next. Question number 16. पिछली बार नहीं थे जो लोग, ये pulses हैं, you can generate pulses in the thread and they move, you know, these pulses move. And I told that if there is a boundary and the boundary is rigid boundary, then these pulses strike the rigid boundary and reflect back. There could be another case of a thick wire and the thin wire joining together. And the entry of the wave from the thin wire to the thick wire is not that easy. Whereas the entry of the wave from the thick wire to thin wire is easy. So what is the meaning of not that easy? When it reflects back, it just carries a phase difference of pi. मतलब crest approach करेगा अगर, ठीक है, thick wire पे लौटने वाला जो wave होगा thin wire में वो trough होगा. पाई का फेज डिफरेंस आ गया, डायरेक्शन भी बदलेगा. कुछ इस तरह के मैंने केसेस करा रखे थे पिछले. यहाँ खैर ऐसा नहीं है, यहाँ दो पल्सेस हैं अपोजिट डायरेक्शन में आ रहे हैं एंड दे आर जस्ट गोइंग टू नाउ क्रॉस ईच अदर. यू हैव टू थिंक ओवर from the, it's not a question where you need to calculate something, just think over from the conceptual aspect. टू सेकेंड जानबूझ के दिया है इन्होंने. गेस करो 2 सेकेंड में क्या होने वाला है. दोनों मीट कर जाएंगे, ठीक है, क्योंकि 2 सेकेंड में दोनों 4-4 सेंटीमीटर चल लेंगे. और अब क्या होगा जब ये मीट करेंगे तो दे विल किल ईच अदर. ओके, देन व्हाट आर द करेक्ट ऑप्शन? लॉक करो सर, लॉक करो, इनको दिखाओ लॉक करके. आई थिंक दे मस्ट, बिकॉज़ इट्स कंसेप्चुअल ना, सो दे कैन हैव अ री थिंकिंग अगेन इफ समथिंग गोज रॉन्ग. आंसर इज नॉट ए. सर सही लॉक किया है, बी इज द करेक्ट आंसर. सो थिंक अगेन. दिखाना सर द ऑप्शंस. Where the energy has gone, Urja, if I accept your answer, how do you justify your answer? Where the energy has gone? Who has killed it? किसने एनर्जी खत्म, कहां हुई एनर्जी? I mean, कहीं तो एनर्जी गई होगी. If I say 0, then एनर्जी कहीं गई. and where the energy has gone. Thread has become very hot. देखिए एक तरीका नॉर्मली हम लोग का फिजिक्स वालों का होता है हीट एनर्जी, जहां कहीं नुकसान हुआ, ठीक है. I wonder that it doesn't happen there. So law of conservation of energy doesn't allow you to accept that answer first part. And when the waves, when there's a string, actually a string has a pulse, then energy is actually, when there's a pulse form, its energy is potential form. Because remember, potential energy is what? The energy due to the special configuration. And what is kinetic energy? Energy due to motion. Okay, so pulse was moving, so energy was having both potential as well as kinetic. And when they meet, what are you going to kill? If at all you kill, potential, because the amplitude is going to nullify, but the kinetic is going to survive. That you can't kill. Okay. What happens after that? That's a different issue. कहाँ जाएगा, कौन सा किधर move करेगा? After that, maybe there is another wave generated which started moving. Okay, with no pulse, the thread continues to vibrate. Some kinetic energy survives in the medium, but okay. So B is the correct option, purely kinetic. Next, sir. चलो बहुत बढ़िया. Try करो. 17. Your Doppler effect. So original frequency is 5 kilohertz. And remember, the siren has been placed at the station. Okay, station पे siren बज रहा है. A passenger sitting in a moving train A records a frequency of 5.5 kilohertz. Moving train A. ये छोटी सी ट्रेन है. He records a frequency 5,500 hertz. Okay, apparent frequency, say nu A. While the train approaches the siren, during his return journey in a different train B, he records a frequency of 6 kilohertz while approaching the same siren. अगली ट्रेन में ये आ रहा है और अब इसको 6000 hertz की frequency सुनाई दी. The ratio of the velocity of the train B to train, ये फटाफट कर लो, ये तो आसान है. क्या है आंसर? मैं आपकी जगह होता था ऐसे करता. ऑब्जर्वर चल रहा है या रेस्ट पे है? ओके, किधर चल रहा है, पॉजिटिव और नेगेटिव डायरेक्शन? है नेगेटिव ना. ओके, सो नेगेटिव पे ये v प्लस v हो जाता है. ठीक है, एक केस. अगला केस, ठीक है? How many unknown? 3 unknown. VA, VB and V. So probably V has to be used. In case if we require V to be used, you can always use 350 meter per second velocity of sound in air at room temperature. Last time I told you at 0 degree centigrade it is 332 meter per second, but as the temperature increases, per degree rise in temperature increases the velocity of sound by how much? 0.61 meter per second. Okay, so roughly 25 डिग्री सेंटीग्रेड में वो बढ़कर 345 350 हो जाता है. So divide करो, you can say 60 upon 55 is equal to V plus VB upon V plus VA. Fine. So 12 by 11 is equal to 350 ले ले, 350 plus VB upon 350 plus VA. Cross multiply, a componendo, dividendo, if you want to apply, or cross multiply. So any Tom, Dick and Harry can do that. If I multiply, I get 11 into 350 plus 11 VB, I mean, is equal to 12 into 350 plus 12 VA. Fine. So 12 minus 11 350 is equal to 12 VA minus 11 VB. Okay. गड़बड़ तो नहीं है? 12 minus 11 350 इस तरफ ले गया मैं. Okay, 11 minus 12. Oh, it's okay, fine. So this is 350 is equal to minus 12 VA plus 11 VB. You have to find VA by VB. अलग से भी निकाल सकते थे हम लोग. We could have found VA from this equation and VB from this equation, because V तो हम ले ही रहे हैं. Okay, and once you know VA and VB, you can find the ratio VA to VB. ठीक है? Is it okay? Should I move on? कौन सा आंसर है से बता दो. B, that is 2. So they can calculate, no problem. That's not that big issue. Next. A sonometer wire. Question देख लो, थोड़ा पोर्शन उस अगले पेज पे होगा, पहले यहाँ देख लो इतना. Sonometer wire resonates with a given tuning fork, forming standing waves with 5 antinodes between the two bridges. When a mass of 9 kg is suspended from the next page, from the wire. Make the diagram, make 5 antinodes. If there are 5 antinodes, then in which harmonic the sonometer wire is vibrating? 1, 2, 3, 4, 5. Which harmonic? 5th harmonic. Actually number of antinode is the harmonic. Okay, so 5th harmonic की frequency क्या होगी? Nu 5 by 2L T by mu. Okay, when the mass is replaced by mass m, what was the aerial mass? उसमें क्या था, कितना mass था? देखना सर उसके, what was the mass given? 9 kg. This happens when the mass was 9. When the mass is 9 kg, what will be the tension? 9g. Fine. Have you seen the tuning fork? The sonometer wire? There's a weight suspended here, and that weight produces the tension. Tension will be the weight of the wire, the weight which you have suspended from the hanging balance. So 9g is the tension. Next time it is given that, next page, when the mass has been replaced by m, the wire resonates with the same tuning fork, forming 3 antinodes for the same positions of the bridge. Right now, nu 3 by 2l root t dash by mu. Where t dash is mg. How many of you have done this experiment, tuning fork, paper, when you keep a paper there in the tuning fork and then you hit the tuning fork and keep on the sonometer device, then the paper flies off. Okay, it really flies off, but paper should be very small. You can't keep a page there, okay, on the wire. It has to be very small paper, clink. So when it happens, the frequency of the tuning fork matches the frequency of the wire. And I told last class, this is called resonance. This phenomena of matching two frequencies of two independent sources is called resonance. And since the same tuning fork is causing the resonance for these two cases, that means these two frequency will be equal. Kar do equal, you get the answer. जल्दी बताओ कितना आंसर है? Tell me, what is M? 25. बताओ sir. A is the correct answer. Good children. IIT JEE 2002 का क्वेश्चन सॉल्व कर दिया आपने. भविष्य बहुत उज्जवल है. Next, question number 9. Question number 9. Good one. Reading it. Police car moving with 22 meters per second clashes a motorcyclist. The policeman sounds his horn at 176 hertz, while both of them move towards a stationary siren of frequency 165 hertz. Chases a motorcyclist. The policeman sounds his horn at it's a chases, not clashes actually. उसको अभी एक्सीडेंट नहीं होते. It's just chasing. 176 hertz is the frequency of the policeman horn, and the stationary siren has 165 hertz. Motorcyclist does not observe any beats. What is the meaning of this? Motorcyclist does not observe any beats. उसको सुनाई नहीं दिया, बहरा था. हाँ, ठीक है, बहरा नहीं था, उसका कान ठीक था, काम कर रहा था. But the same thing which I spoke today, that he has got the limit. Okay, so 10 hertz लेके कर सकते हो क्वेश्चन. Other centered children, can also tell me the answer in case if they are able to do. In case if you get the answer, please let me know. ये भी मैं सॉल्व करूं? करो, आप ट्राई करो. First, in both the cases, police car as well as the motorcycle, they are moving in positive or negative direction. पहले ये डिसाइड करो. नेगेटिव डायरेक्शन. तो फटाफट बताओ पुलिस कार के लिए अपरेंट फ्रीक्वेंसी, ओरिजिनल फ्रीक्वेंसी, हैज इट बीन गिवन 165 हर्ट्ज. In fact, we need not to go for the police car. Motorcycle के केस का कंसिडर कर लेते हैं. Motorcycle has got a apparent frequency of say mu, that is going to be 165. Tell me, v, velocity of sound. Motorcycle is observer, so he is moving towards the stationary siren. So v plus vo upon v minus 0. Is it okay? This is the case when the motorcycle, I have considered motorcyclist is listening the sound which is being emitted by the stationary siren, but he is going to listen another sound also. This time he is going to listen the sound of the policeman. Let us see. मोटरसाइकिल ने पुलिस वैन का जो सायरन सुना, stationary siren, policeman, follow 176. Fine. They both are moving now. Look, observer is moving, source is also moving. In which direction? They both are moving in the positive direction. That means V minus VO upon V minus 22. ठीक है ना? V is given 330 मीटर पर सेकेंड. तो इस केस में 165 330 प्लस VO अपॉन 330, यहां 176 330 माइनस VO upon 330 minus 22. इतना समझ में आ गया? What I have done here, I have considered the poor motorcyclist struggling to hear the sound of the siren which is stationary and the sound which the policeman is emitting while the policeman is chasing that motorcyclist. Now the motorcyclist is going to claim that what he has heard, the two frequencies, that difference is going to be more than 10 hertz. We can use 10 hertz for our boundary condition and then move on. So 10 hertz से कम होता अगर तो वो सुन लेता, लेकिन चूंकि 10 hertz या 10 से ज्यादा था इसलिए वो नहीं सुन पाया, उसने क्लेम किया. तो इसका मतलब 10 लेकर अगर मैं सॉल्व करूं, I can get nu m dash minus nu m is 10 is given. वैल्यूज डालिए. 1 मॉड ले लेना ताकि कहीं कुछ माइनस का चक्कर ना आए. ठीक है, क्योंकि आपको नहीं पता ना कि कौन सा ज्यादा है. मॉड लेके कर लो. दैट मीन्स 165 330 प्लस VO अपॉन 330 माइनस 176 330 माइनस VO अपॉन 330 में से 22 निकला, कितना बचा? 308 mod 10. How many variable? Only one, VO. Solve it. Tell the correct answer. It's not that easy calculation. बहुत सारा क्रॉस मल्टीप्लाई वगैरह करना होगा आपको. So should I move on? Homework. ठीक है, जैसे स्कूल में होता है जब क्वेश्चन स्टफ होता है तो टीचर सारा होमवर्क दे देते हैं बच्चे करेंगे. आगे बढ़ते हैं. होमवर्क. सर होमवर्क आंसर बता दो इन्हें. है B is the correct answer. 22 मीटर पर सेकेंड. चाहो तो चेक कर सकते हो इसमें 22 रख के. ऐसे कर लेते, चेक कर लेते. आ गया, किसी का आया? ओके, 22 यहाँ रखो तो 330 प्लस फिर भी चेक करने में भी मल्टीप्लाई करना होगा, डिफरेंस लेना होगा. इट्स अ होमवर्क. फाइनली इट्स अ होमवर्क. नो डाउट इट्स अ होमवर्क. ओके, मूव ऑन. I have already done it. In fact, so mathematics I don't want to do in physics class. Next, in an experiment for the determination of sound of velocity of sound in air using the resonance column method, the length of air column that resonates in the fundamental mode with the tuning fork is 0.1 meter. I presume that all of you have done that experiment where we find the velocity of sound. What was the formula? What was the formula to find the velocity of sound? बताओ. क्या प्रिज्यूम करो जब आप फॉर्मूला भूल गए? अभी तो 11th पास भी नहीं हुए, रिजल्ट नहीं आया होगा अभी. Velocity of sound is 2 nu L2 minus L1, where nu is the frequency of TF and L2 is the second resonating length of air column. याद आया कुछ? ठीक है. And L1 is the first resonating length. अब आप ट्राई करो. एंड करेक्शन का फॉर्मूला बताया था ना बेटा लास्ट क्लास में? यस, रेज योर हैंड दोस हु वर प्रेजेंट देयर. आई वाज प्रेजेंट. बताया था. व्हाट वाज द फॉर्मूला? एंड करेक्शन. भूल गए? लगता है पिछली क्लास के बाद आज ही शुरू किया पढ़ाई, एक हफ्ता. एंड करेक्शन इज E is equal to, आपको भी याद नहीं है? L2 minus 3L1 upon 2. ये एंड करेक्शन का फॉर्मूला है. ठीक है. और एक चीज बताई थी, सब मुझे याद रहेगा. एंड करेक्शन फॉर ओपन आर्गन पाइप इट इज 0.6 into 1.2 R, where R is the radius, and for closed organ pipe it is 0.6 R, where R is the radius. ठीक है. These data are already available in my notes. You can see and learn the formula. Now I think it's now easier, most easy question to do. IIT JEE 2003. Look at this standard. If you know the formula, L2 and L1 has been provided here. Substitute, you get the answer. Come on, do at least this question. हाँ, seems to be. Yes, sir. B is the correct answer. Next. फॉर्मूला लिख लो, नोट कर लेना फॉर्मूला. एंड करेक्शन एज वेल एज द वेलोसिटी ऑफ साउंड. और वो भी लिख लेना कि एंड करेक्शन इज जनरली 0.6 R फॉर क्लोज्ड OP organ pipe and it is 1.2 R for open, OP. Okay, next one. What changes when the sound goes from one medium to another? Frequency, wavelength, speed, none of these. None of these? All three? So I have to tell you, probably this is a very important concept. Frequency of light or frequency of sound, it doesn't changes when it goes from one medium to another. It is the wavelength on, obviously अगर frequency नहीं बदला तो wavelength and speed will change क्योंकि v equal to nu lambda. ठीक है, ऐसा हो ही नहीं सकता कि मैं ये ना बदलूं और ये दोनों भी अनचेंज रहें. अब अगर ये बढ़ गया तो ये बढ़ेगा, ये घट गया तो ये घट जाएगा, बट दिस रिमेन सेम. इन फैक्ट ड्यूरिंग एनी फेनोमेना, रिफ्लेक्शन, ठीक है, रिफ्रैक्शन, लाइट के लिए भी साउंड के लिए, दोनों के लिए बोल रहा हूं, ठीक है, फ्रीक्वेंसी रिमेन सेम. इट इज दैट इनहेरेंट इनबिल्ड प्रॉपर्टी ऑफ वेव सोर्स जहां से वेव जनरेट होता है. ठीक है, अभी जो डॉपलर इफेक्ट में फ्रीक्वेंसी बदल रहा है, ध्यान रहे, फ्रीक्वेंसी सोर्स जो एमिट कर रहा है वो नहीं बदल रहा है. चलता हुआ सोर्स वही एमिट करता है जो रुक के करता है. वो तो आपको सुनाई अलग देता है बिकॉज यू आर एक्चुअली हैविंग सम रिलेटिव मोशन, बट फ्रीक्वेंसी रिमेन सेम. फ्रीक्वेंसी बदलना है तो क्या करना होगा? सोर्स की ओरिजिनल कैरेक्टरिस्टिक चेंज करनी पड़ती है अगर फ्रीक्वेंसी बदलना होगा. ठीक है, मुझे अगर आपकी तरह बोलना होगा, लड़कियों की तरह ऐसे कुछ कर, कुछ ना कुछ वोकल कॉर्ड में मुझे कुछ करना होगा कुछ, तो मैं बदल सकता हूं आवाज. बट द फ्रीक्वेंसी रिमेन्स इनहेरेंट एंड इनबिल्ड एबिलिटी ऑफ द सोर्स ओनली. भूलना मत कभी भी. ठीक है, आंसर क्या होगा इसका? 600 हर्ट्ज. आगे बढ़ जाएं सर, सही है ना? कहीं गलत तो नहीं है? अरे वाह, क्या बात. नेक्स्ट, चलो एक कंसेप्ट बिल्ड हो गया. नेक्स्ट क्वेश्चन नंबर 22. गुड वन अगेन. अ क्लोज ऑर्गन पाइप ऑफ लेंथ L, थोड़ा सा फॉन्ट, हाँ बस बस बस. Organ pipe of length L and open organ pipe contains gases of densities ρ1 and ρ2 respectively. The compressibility of the gases are equal in both the pipes. What is compressibility, children? Reciprocal of the bulk modulus. Bulk modulus का उल्टा is a compressibility. Okay, fine. Both the pipes are vibrating in their first overtone with the same frequency. The length of the open organ pipe is, करो करो करो, try करो. ओवरटोन बताऊं या आता है? आता ना? ये है क्लोज ऑर्गन पाइप, इसका फर्स्ट हार्मोनिक ये है, और ये है ओपन ऑर्गन पाइप, इसका फर्स्ट हार्मोनिक ये है. ऐसे ओवरटोन बना लोगे? ठीक है. फर्स्ट ओवरटोन इसका क्या होगा? इसका फर्स्ट ओवरटोन क्या होगा? ठीक है, डीएनए की तरह स्ट्रक्चर बन जाता है ये. एंड दिस इज फ्रीक्वेंसी के टर्म्स में, इसकी फ्रीक्वेंसी V/4L, इसकी फ्रीक्वेंसी नहीं, कह दो कि ये झूठ है, V/3V/4L, ये V/2L, ये वेरी गुड. तो इसका मतलब nth हार्मोनिक की यहां फ्रीक्वेंसी क्या होगी, एन न्यूएन, यहां nth हार्मोनिक की क्या होगी, वेरी गुड। चलो जी, अब ट्राई करो, ये नोट कर लो जो लोग नहीं थे पिछली क्लास में। वेलोसिटी ऑफ साउंड भी बता दूं, व्हाट इज द वेलोसिटी ऑफ साउंड इन एयर, नहीं तो वैल्यू फॉर्मूला, there are two formula, one was given by Newton, another one given by Laplace, gamma p by rho, and Newton simply p by rho, where p happens to be pressure, gamma happens to be Cp by Cv. All right, for mono, for di, and for tri, they are different. Fine. If I don't address this in terms of gamma p and p, actually they happens to be modulus of elasticity also. P happens to be the modulus of elasticity of gas at constant temperature, and gamma p happens to be the modulus of elasticity of gas at variable temperature when there is a adiabatic changes. Okay, so probably this should be written like this, modulus of elasticity upon rho. Better way to write. With modulus of elasticity of gas is reciprocal of the compressibility. Okay, so if the compressibility is K, then E will be 1 upon K. So I can also write this formula as 1 upon K rho, where K is the compressibility. That is 1 upon E. ये वेलोसिटी ऑफ साउंड है। ठीक है, आपको जरूरत पड़ेगी इसलिए मैंने बताया, अब आप यूज करो और फिर हो सकता है आपके आंसर में रो 1 और रो 2 बाद में रह जाएं। हाँ सर, लेट देम ट्राई। This is the correct answer. D. एक बार चेक कर लो दोबारा। क्योंकि उसने लेंथ ऑफ द ओपन ऑर्गन पाइप पूछा है। अब सी है, क्या अब लास्ट क्लास में आप बड़े एनर्जेटिक थे, बहुत, मुझे लगा था कि शी इज वेरी एनर्जेटिक डूइंग ऑल द क्वेश्चंस, सडनली आज क्या हो गया? बल्कि आप, मुझे याद है एक क्वेश्चन भी आपने बोर्ड पे आके सॉल्व किया था, रिमेंबर? अच्छा, यू डिड, यू आल्सो डिड, आपका क्वेश्चन सॉल्व किया था ना बोर्ड पे आके लास्ट क्लास में? नहीं, अच्छा क्या था, करो करो। सी इज द करेक्ट आंसर। नेक्स्ट करें या बताएं? शुड आई सॉल्व इट? आपसे हुआ, सिर्फ ऊर्जा आपसे हुआ ना? इनको पनिशमेंट दे ही देते हैं, फिर इनको बुला के सॉल्व कराते हैं। बहुत जल्दी जल्दी कर रहे हैं, अगली बार से करना बंद कर देंगे। सी मस्ट टेक इट एज ए कॉम्प्लीमेंट, कहीं से लगे कि मैं। यस बेटे, आ जाओ, करो। या मैं कर दूं? ओके, चलो, लेट मी डू इट। दे आर closed pipe of length L and open pipe containing gases of density rho and rho respectively. The compressibility of the gases are equal to both the pipes, and both the pipes are vibrating in their first overtone. Closed pipe, let LC is the length of closed pipe. First overtone. So what is the frequency? 3V close, 3V air, I mean V upon 4L close. ठीक है, ये फॉर्मूला होता है। फाइन। Now for open pipe, first overtone, let this be L open, length L open. ठीक है, this L close is given as L. L open has to be calculated. What is the frequency? Come tell me. New first overtone की frequency क्या होगी? V upon, let it be V dash, because densities are different, the velocity will not be same, upon 2L O, where LO stands for the length of the open pipe. Fine, इतना clear है? Both the pipes are vibrating in their first overtone with the same frequency. Equal कर दो frequencies. आ जाओ. nu2 here is equal to nu2 there. So equal करने के बाद क्या मिला? 3v by 4l is equal to v dash upon 2lo. ठीक है? Is it okay? 2 से ये 2 cancel, 4 cancel. So what we have got here? LO is equal to 2L upon 3 V dash upon V. इतना ठीक है? क्या समझ आ गया? अब आपको V dash by V निकालना है, which will be, इसके पहले मैंने बताया था आपको velocity of sound क्या बताया था? It was 1 upon K rho. That means V is proportional to rho if K remains constant. That means V dash by V. V dash किसका मैंने लिया था? ओपन का। गैस का डेंसिटी देख लो, रेसिप्रोकल होगा। That means this will be 3L by 2L by 3, ठीक है, rho 1 by rho 2. Okay, so C is the correct answer. Next one. ये ओपन पाइप क्लोज पाइप बहुत हो गया। जरा डॉपलर इफेक्ट पे चलते हैं, नीचे चल और पीछे चलिए. नेक्स्ट लेट्स डू सम क्वेश्चंस प्योरली बेस्ड ऑन डॉपलर इफेक्ट. वॉल रिफ्लेक्टिंग, पहाड़ की कोई ऐसी चोटी है जिससे साउंड रिफ्लेक्ट हो रही है, समथिंग लाइक दैट. आगे होगा जरूर. देखिए ये कर लेते बच्चे. क्वेश्चन नंबर 25, जस्ट लेट देम ट्राई. क्वेश्चन नंबर 25. बहुत बढ़िया क्वेश्चन है. मैकेनिक्स भी आएगा थोड़ा सा, बहुत दिन हो गया कि मैं भूल रहे होंगे आप मैकेनिक्स, रोटेशनल इक्विलिब्रियम एंड ऑल दैट. चलो देखते हैं, कोई नहीं. Should I explain? There's a rod and the rod has been suspended by two threads of equal length. Okay, answer my question. If suppose I ask you tension in the threads, I don't suspend the mass m. Suppose rod has a mass, yahan to rod massless hai, but if the rod has a mass and I suspend with the equal length, what would be the tension in the thread? mg by 2 each. Equal means mg by 2 each. ठीक है, इतना क्लियर है. Rod doesn't have any mass, so whatever tension we are going to create in the rod, that is going to be only because of this. But are the tension going to be equal now, the manner through which I am suspending it? Answer should be big no. So किस तरफ टेंशन ज्यादा होगा? लेफ्ट की तरफ टेंशन ज्यादा होगा. जिधर टेंशन ज्यादा होगा उधर फ्रीक्वेंसी भी डिफरेंट होगी, क्योंकि फ्रीक्वेंसी इज डायरेक्टली प्रोपोर्शनल टू टेंशन. ठीक है, भले ही सेम ट्यूनिंग फॉर्क से आप दोनों को ऑसिलेट कराओगे, लेकिन फ्रीक्वेंसी अलग अलग जनरेट होगी. फाइन, ये बात समझ में आ गई. ये एक्स पे है, इस पे टेंशन हम T1 ले लेते हैं, इस पे T2 ले लेते हैं. लेकिन एक बात तो सच है, T1 T2 लेने के बाद भी एक बात सच है. और क्या है वो बात सच जो है? T1 प्लस T2 विल ऑलवेज बी इक्वल टू mg. T1 ज्यादा होगा, एग्रीड, but T1 plus T2 will always, because the mechanics says that the body is at rest, equilibrium. Fine, is that okay? Okay, so before you actually start doing the problem, the conclusion first thing should be in mind that the T1 plus T2 is equal to mg. And now just see that which of the thread is vibrating in which particular tone. If the fundamental frequency of the left wire is twice the fundamental frequency of the right wire, मतलब दोनों fundamental frequency में है, लेकिन frequency का difference है, तो एक की fundamental frequency निकालो, दूसरे की fundamental frequency को 2 से multiply कर दो. ठीक है, is that okay? x की वैल्यू निकालनी है. चलो ट्राई करो. अभी तक लेकिन x कहीं आया नहीं, क्योंकि मैंने आपको जो बताया वो T1 प्लस T2 इक्वल टू mg बता दिया, वो तो एक इक्वेशन आ गया. फंडामेंटल फ्रीक्वेंसी की बात हो रही है, तो ज्यादा से ज्यादा क्या कर सकते हो? एक की फंडामेंटल फ्रीक्वेंसी, लेफ्ट वाले वायर की फंडामेंटल फ्रीक्वेंसी लिखो, 1/2L रूट T1, ठीक है, इज इक्वल टू ट्वाइस अपॉन 2L रूट चलो T2 बाई म्यू लिख देता हूं. Then LL cancel, mu mu cancel, 2 2 cancel, T1 is equal to 42 इक्वेशन 2 x तो निकला नहीं। क्या रहे बताओ, गेस करो क्या करना चाहिए। हा? इसकी लेंथ दी है, BD की लेंथ। हाँ स्मॉल l दी है, आंसर से पता चल रहा है, ठीक है, ऊपर डेटा में कहीं नहीं है, बट इसकी लेंथ आंसर से पता चल रहा है क्योंकि लेंथ के टर्म में आंसर है सारे। तो मैं BD की लेंथ अगर L मान लूं और P के अबाउट टॉर्क निकाल लूं, ठीक है, याद होगा रोटेशनल इक्विलिब्रियम जब कराया था मैंने गुड़गांव में, remember, then we took the torque about our point of choice. The point of choice, if you remember, should be the one where you get maximum number of forces passing so that उसका जो टॉर्क है उस उन तमाम फोर्सेस का वो जीरो हो जाए। तो यहाँ पर दो ही टेंशन बचेगा। मैं P के अबाउट टॉर्क निकालूं तो दोनों दोनों टेंशन का टॉर्क बता दो। T1 का टॉर्क क्या होगा P के अबाउट, T1 इंटू एक्स, समझ आ गया, क्लॉकवाइज या एंटी क्लॉकवाइज। T2 का टॉर्क, अब सॉल्व हो जाएगा, अब एक्स आ जाएगा। ये यूज कर लो, ये यूज कर लो, इसको बोलो जय राम जी की, इसकी कोई आवश्यकता फिलहाल नहीं है, कोई बात नहीं। T1 प्लस T2 इक्वल टू mg है तो है। टेल द आंसर। L भाई 5, ठीक है, सही होगा सर, इतने सारे बच्चे एक साथ बोल रहे हैं, गलत नहीं हो सकता। नेक्स्ट, मुझे डॉपलर इफेक्ट चाहिए, मुझे मजा नहीं आ रहा, और चाहिए जैसे डॉपलर होगा तो ठीक है, नहीं तो फिर हम चलेंगे उधर, छोड़ दो, गो फॉर द दोज नोट्स, उसमें मैं डॉपलर इफेक्ट के बहुत सारे क्वेश्चंस हैं। एक मिनट, लास्ट क्वेश्चन था डॉपलर इफेक्ट, दिख गया डॉपलर इफेक्ट दिखाइए जरा, यस ये वाला, हाँ अच्छा सा बड़ा सा क्वेश्चन है, जनरेट बीट्स, नहीं तो बीट्स का है, गो टू दैट नोट्स, 56 क्वेश्चंस वाले जो नोट्स थे अभी जो, यस, इनमें से कोई सा भी एक करो, इसमें डॉपलर इफेक्ट बहुत मिल जाएंगे, एनीथिंग यू कैन ओपन, यस जस्ट अ मिनट, उधर आ जाओ, उधर आ जाओ, उधर जाओ, नेक्स्ट नेक्स्ट पेज, नेक्स्ट पेज, नेक्स्ट, क्या यार, क्वेश्चन नंबर 49, क्वेश्चन नंबर 49, थोड़ा सा कम करिए, चिल्ड्रन अटेम्प्ट इट, a whistle emitting a sound of frequency 450 hertz approaches a stationary observer at a speed of 33 meter per second. A whistle emitting a sound of frequency 450 hertz approaches a stationary observer at a speed of 33 meter per second. Velocity of sound is 330 meter per second. The frequency heard by the observer is, jaldi se kar lo, you do it quickly, and then I give you another problem of Doppler effect of my own. कर लो, कितना आया? कितना बेटा? ठीक है, आंसर चेक कर लो, वैसे वही होगा। क्वेश्चन नंबर कौन सा था? 49। 49 नहीं, इसमें नहीं होगा आंसर, तो इसका अलग से आंसर पेज होगा। देयर इज अनदर आंसर पेज हियर, यू गो बैक, इसी का लास्ट पेज आंसर पेज है ये। 49, 49 का डी सही है। ठीक है, जरा इस क्वेश्चन को करते हैं ट्राई। ठीक है, लेट्स सी, आई वांट यू टू डू दिस। देयर इज अ सोर्स व्हिच इज मूविंग टुवर्ड्स स्टेशनरी वॉल। ओके, नोट करना चाहो नोट कर लो। ठीक है, तो आप भी आराम से बना सकते हो ऐसे क्वेश्चंस अपने प्रैक्टिस के लिए। देयर इज अ सोर्स व्हिच इज मूविंग टुवर्ड्स स्टेशनरी वॉल and the source is emitting a frequency of 512 hertz. The velocity of sound is 350 meter per second. The source, this source happens to be a car being driven by a driver. And the driver claims that he hears a frequency reflected by the wall such that the beat frequency between his own horn which he is hearing and the one which he receives from the wall is 8 hertz. This is his claim. So beat frequency of the driver is 8 hertz. Calculate the velocity of the car. Okay, try it. Calculate the velocity of the car. I repeat, there is a car moving towards a stationary wall and the car driver claims that he heard beat frequency of 8 hertz. Where the beat will be produced? Because he is going to hear two different frequencies, one of his own car horn which he is pressing and the other which get reflected from the wall. Chalo, shuru karo. Start doing. You can close it. अब इनको मैं एक या दो क्वेश्चन ऐसे कराऊंगा थोड़े घुमावदार। I will love to hear if you tell me what frequency this driver receives which comes from the wall. What frequency he receives. इसका फॉर्मूला क्या होगा डॉपलर इफेक्ट के एंगल से? क्योंकि 80% प्रॉब्लम इसी में है। अगर ये आपने लिख लिया तो फिर बीट फ्रीक्वेंसी के बाद तो डिफरेंस करके निकाल ही लोगे। जवाब दो मेरे बात का। Will he receive what is being reflected by the wall? Will he receive what is being reflected by the wall? Answer is big no. Why? Because he is not at rest. He is running. He is moving towards the wall. Has it been the driver at rest? Then the answer could have been yes. जो वॉल रिफ्लेक्ट करेगा वो ड्राइवर रिसीव करता, अगर वो रेस्ट पे होता तो. ड्राइवर इज नॉट एट रेस्ट. दैट मीन्स ड्राइवर इज गोइंग टू रिसीव समथिंग एल्स देन व्हाट द वॉल इज रिफ्लेक्टिंग. समझ आ गया? अब जरा वॉल के एंगल, वॉल क्या रिसीव करेगा? विल द वॉल रिसीव, जब वॉल ने रिफ्लेक्ट किया, विल द वॉल रिसीव इससे जो आ रहा है, द वन विच इज सेंड बाय द ड्राइवर. विल द वॉल रिसीव frequency one which has been sent by the source here? Answer is no. Why? Because this source is not a stationary source. It is a running source. इतना समझ में आ रहा है ना? अब एक और सवाल, लास्ट सवाल, आखिरी सवाल. Will the wall reflect what it receives? The answer is big yes. Why? Because wall तो कुछ नहीं करेगा ना. Wall is not moving. It is just going to just accept and reflect. That's it. Complicated cases में क्या और हो सकता है? वॉल को भी चला दूं, ठीक है, वॉल को भी चला दूं, और वॉल को कई तरीके से चला सकता हूं. वॉल को मैं इसकी तरफ चला सकता हूं, इधर चला सकता हूं, और थोड़े थोड़े और अच्छे अच्छे पंगे हो सकते हैं इसमें, लेकिन फिलहाल इसको ऐसे अप्रोच करते हैं. आपने कहा कि इसने जो रिसीव किया वो नहीं है जो इसने फेंका, तो इसने जो रिसीव किया उसको मैं न्यू वन मान लेता हूं. ठीक है, समझ आ रहा है? और इसने जो रिफ्लेक्ट किया वो वही है जो रिसीव किया, इसका मतलब इसने रिफ्लेक्ट क्या किया होगा? न्यू वन. लेकिन इसने जो वापस में रिसीव किया वो नहीं होगा जिसने रिफ्लेक्ट किया, तो मान लेता हूं वो न्यू टू है जो इसने रिसीव किया. अब आ जाओ, पहले न्यू वन की बात करो मेरे से. जब इसने रिसीव किया तो ये क्या है? सोर्स या ऑब्जर्वर? वेरी गुड, ऑब्जर्वर रेस्ट पे है. न्यू वन क्या होगा? न्यू ओरिजिनल v अपॉन, बोलो, v माइनस या प्लस? माइनस vs निकालना है. बहुत बढ़िया, ठीक है. अब इसने जो रिसीव किया, न्यू टू, आ जाओ बोलो, इसने जो रिसीव किया उसके लिए ओरिजिनल ये होगा. अब ये क्या है? सोर्स या ऑब्जर्वर? और ये, वेरी गुड, कौन रेस्ट पे है? सोर्स या ऑब्जर्वर? वेरी गुड. प्लस या माइनस? विल मेक मी डांस, नथिंग एल्स. प्लस या माइनस? देखो, कोई माइनस कोई प्लस. प्लस ना. Because this is the source and this is moving in opposite direction to the positive direction. Source to observer हमेशा positive होता है. Fine. न्यू वन की वैल्यू डालो. आप भी बीट सुना रहे हो, मुझे मेरी आवाज मुझे सुनाई दे रही है, बट 10 हर्ट्ज से कम है लगता है. आई कैन हियर माई साउंड एज वेल एज द साउंड विच, यहां से भी आ रही है आवाज. ओके, बड़े चतुर हो तुम. न्यू ओ वी प्लस vs अपॉन v माइनस vs. ये समझ आ गया? v कैंसिल, ठीक है. इज इट ओके? बीट फ्रीक्वेंसी कितना दिया है? सॉल्व कर लो vs के लिए. vs के लिए सॉल्व कर लो. Any problem, Urja? Solve it, na? Then hurry up. Sir, is there any online question? As if there's no online question. Such a bad was my teaching today. Achha, but they're not asking any question. Okay, fine, good. कितना है बच्चों बोलो 512 350 प्लस वी एस अपॉन 350 माइनस वी एस माइनस 512 ये होगा ना सो 512 350 plus Vs upon 350 minus Vs 520 350 plus Vs upon 350 minus Vs 520 upon 512 कैंसिल नहीं हो रहा ये कैंसिल करो वन 130 by 103 ना ओके क्रॉस मल्टीप्लाई 350 128 okay 130 by 128 350 into 130 minus 130 Vs is equal to 350 into 128 plus 128 Vs. How much? Then we get 350 130 minus 128 is equal to 130 plus 128 Vs. Okay, therefore Vs is 350 into 2 upon 258 is how much? 350 upon 129 meter per second. Okay, you can calculate it using calculator or leave it like this. Got it? We can do one more question. Okay. Let's club simple harmonic motion with the Doppler effect. See how to club it. Maybe there is a source and the source is performing SHM. Okay, with given frequency. To and fro motion. It could be a speaker. Okay, for example, if I'm a source, I might start moving to and fro towards from mean position. Now, if there is another detector which has been kept here or here or here, these are the three positions of the detector. There could be Doppler effect. The detector might receive different frequencies than the original frequency. what is being emitted by the source. Agreed or not? पहले इस पे चर्चा कर लें, होगा अलग कि नहीं होगा? एक केस में शायद ना हो. कौन से केस में, कौन सी पोजीशन डिटेक्टर की ऐसी है जिस केस में नहीं होगा डॉपलर इफेक्ट? इस केस में नहीं होगा, क्योंकि इस सोर्स का कंपोनेंट लो इधर, 90 डिग्री पे कंपोनेंट क्या होता किसी वेलोसिटी का? किसी वेलोसिटी का 90 डिग्री पे कंपोनेंट नहीं होता. ठीक है, दैट मींस ये जो केस पोजीशन है डॉपलर इफेक्ट के लिए ठीक नहीं है. जो फ्रीक्वेंसी ये एमिट करेगा वो ये सुनता रहेगा यहां पर. बाकी इन दोनों में होगा डॉपलर इफेक्ट, क्योंकि इस केस में तो बिल्कुल ही होगा, इसी लाइन में है. सो समटाइम्स दिस विल बी मूविंग टुवर्ड्स द डिटेक्टर, समटाइम्स away from the detector. यहां भी होगा, because the component of the velocity of the source is going to be something, okay, one time towards the detector and next time maybe away from the detector. So all that cases can be considered. समझ आ रहा है? In general, difficulty level will be increasing as such by the position of the detector. But let us choose one to move on. चलो मैं ये लेके कर देता हूं. ठीक है, अगर ये केस ले लूं मैं, ये हटा दिया, ये केस ले लूं अगर डिटेक्टर की, तो अब बताओ मुझे मैक्सिमम फ्रीक्वेंसी कब रिसीव करेगा डिटेक्टर? जब ये सोर्स इसकी तरफ आ रहा है या जब इससे दूर जा रहा है? जब तरफ आएगा दूर जाएगा? when it moves towards, obviously. Now when it moves towards during SHM, which is the position where the velocity is maximum? During simple harmonic motion, velocity is not maximum all the time. Velocity is maximum when the body passes from the mean position. That means even if it is moving towards, out of all the positions the source has moving towards, the position when it passes from the mean position will correspond to the maximum apparent frequency. Think about minimum apparent frequency. Again the mean position, but it should move away. ठीक है? Is it okay? Clear है? Which are the positions जब सेम फ्रीक्वेंसी सुनेगा? कौन सी पोजीशन है जब सेम फ्रीक्वेंसी? टू एक्सट्रीम पोजीशंस, क्योंकि एक्सट्रीम पे मोमेंटरली द बॉडी कम्स टू रेस्ट ड्यूरिंग एसएचएम. केसेस समझ में आ रहे हैं ना? ठीक है, डिफिकल्टी लेवल मैथमेटिकली हो सकता है, कंसेप्चुअली आप अगर क्लियर हो तो मैथमेटिक्स डाल दोगे उसमें. तो एक केस लेके कर देता हूं. सपोज करो मैं, मुझसे पूछा गया है कि मैक्सिमम फ्रीक्वेंसी कब मिलेगा, तो न्यू एपरेंट मैक्स वुड बी, बोलो, न्यू ओरिजिनल, source is moving, I think you will agree, a omega, SHM का concept, maximum velocity of any simple harmonic motion. ठीक है, तो चूंकि maximum की बात मैं कर रहा था, observer is at rest, so V upon V plus या minus, सॉल्व कर लेंगे, ओमेगा गिवन होगा, ये दिया होगा. ठीक है, तो इसका मतलब एसएचएम के कंसेप्ट को भी हम डॉपलर इफेक्ट में डाल सकते हैं. फाइन, इज इट ओके? यू कैन नोट इट डाउन. दिस इज न्यू ए मैक्स एंड न्यू ए मिन क्या होगा? न्यू ए मिन विल बी न्यू ओ V upon V plus A omega. ठीक है, इज इट ओके? सर्कुलर मोशन भी डाल सकते हैं. इफ देयर इज अ सर्कुलर मोशन, देन ऑल्सो द डॉपलर इफेक्ट कैन बी अ केस. थिंक ऑफ, इसको नोट कर लिया? आई एम रबिंग इट. ये रहा डिटेक्टर, ये सर्कुलर मोशन हो रहा है, वेलोसिटी यूनिफॉर्म है, वी है. जरा बताइए डॉपलर इफेक्ट की कौन कौन सी पोजीशन में डॉपलर इफेक्ट ऑब्जर्व होगा, कौन कौन से नहीं होगा? बोलिए. Which are the positions? This is source, this is detector, and this is the source. Source is performing uniform circular motion. कौन सी पोजीशन पे लूं मैं डॉपलर इफेक्ट? 1? नो. ठीक है, वाई? बिकॉज None of the velocity component is towards the, bhul jao. 2, yes. 3, no. 4, yes. Out of this marking, I think 2 and 4 I have cleverly taken to be the case which will give you correspondingly minimum and maximum. Out of 2 and 4, बीच में बहुत से ऐसे positions होंगे where there could be Doppler effect, but the frequency heard by the detector will be neither the maximum nor the minimum. बीच का कुछ होगा. As and when जब दिया होगा कर लेंगे, कोई हेडेक लेने की जरूरत नहीं, क्योंकि एंगल जरूर दिया होगा, क्योंकि जादूगर हम भी नहीं है, आप भी नहीं हो. बिना एंगल के रिजॉल्व करके निकाल नहीं सकते. ठीक है, फाइन, समझ आ रहा है? So time is up and the topic is also up. Thank you very much for listening so patiently and asking questions and not asking questions as well, as much as I was willing to, but thank you so much. It has been pleasure once again, children, to speak to you. Thank you.